All right. So yeah, yeah, we start off out domain. Before I yeah, we can confirm. Can we all see the screen? Any reaction is okay. All right. Thank you. Thank you. Yes. So according to Danjuma, she was talking about domain of a function. Um, our professor, the one that taught us, Danjuma Rose Sarah, I think so. That's her name. Yeah. So she gave brief example of what you know the domain of a function is, but you cannot understand the domain of a function, you cannot understand the range, you can't understand um getting range, getting the domain, if you don't know about mapping and functions. So like I said, we're going to go through the basic first before we move into the advanced. So you have to know about mapping, and then you also learn about types of functions and the likes, um, the different types of functions, although those ones are not really something hard or difficult. So let's get to the basic. Yeah. Can you do? All right, so we have to first of all understand mapping, and I'll take it slow. All right. So if you have any questions, you can raise your hand. If you want to make a reaction, you can do that. Okay. So we'll start from mapping. For some of us, we already understand mapping, but let me start from the basic for those that don't understand yet. So about mapping. Now in mapping, we have different types of mapping. Okay, that's what we're going to treat. We'll be treating mapping. 1 second. Let me set this well. So yeah. So now in mapping, there are different kinds of mapping, and we have things that actually should read to one another. It's just like you're trying to mirror an event. That's how mapping is. If you look at the mirror, you match exactly what that mirror is saying. Okay, that's what mapping is. You look at the mirror, you actually match what it is saying, and things like that. So let's take, for instance, we have something like this. We have P to have a set of values, and then we have K to also have a set of values. All right, we have P to have a set of values, we have K to have a set of values. So, and P have elements of A, B, C, and D. And then K has elements of 1, 2, 3, 4. Okay, and let's say 5. So one of them is the domain and one is the codomain. All right. So let's say A matches with 1, B matches with 2, C matches with 3, D matches with 4, and we don't have anything that matches with 5. I will explain that illustration now. If you understand that nothing actually matches with 5 in the value of k, but the domain, okay, the domain of the mapping, all right, the domain of this entire mapping, this is the domain, the one that starts off, and this is our codomain. Okay, so we have the domain and then we have the codomain. Now, the domain of the mapping follows a function. We actually represent it as, okay, the domain would be, we'll have domain of the function to have what? A, B, C, D. That's the domain. Now, this domain is directed towards the codomain, something that reflects it. Okay, so the codomain is what reflects, right? So the codomain has the values, the elements of 1, 2, 3, 4, and 5. Now, when we talk about range, range actually means what is contained in the domain that reflects perfectly in the codomain. That is the range. So if we're going to talk about range, we call it range or we call it image. So the image, so the image or range here, the one that actually reflects, that is 1, 2, 3, and 4. Okay, so we're just trying to understand the entire thing about mapping and functions. So this is about mapping and function. You can see from this clear illustration, you understand that range actually means what is in the domain that reflects perfectly in the codomain. What is in the domain that that consists of things in the codomain that matches perfectly in the codomain. That is what range actually does. That's what it means. So if we're looking at image, or you can call it image, you can call it range. Let's check another one. Let's say we have a function of this. Let's say we have h and we have p. Okay, and then let's say h is reading a, b, c, d. And then p is only reading, p has elements of 1, 2, and 3. A matches perfectly with the first one, B matches with 2, C matches with 3, and let's say D matches with 2 as well. So this is going here, this is going here, this is going here, it's going here. So this is a function. This one now, we call this a function. This can be mapped as a function. This is a function. That is a function. Now, let's check if this is a function. It is a function because everything in the domain matches perfectly what is in the codomain. That's why it's a function, because we have our range, okay? Now, let's see, is this one also a function? Is it acceptable? Is this something that we can work with, right? So the codomain is a set of real numbers, right? So we can say that we have H, okay, reflecting to P. So what is happening here is that, is it acceptable? Yes, it is acceptable. The reason why we say this is also a function, the function of h reflecting to p. The reason why we say it is a function is because every element in the domain, this is the domain, don't forget, every element in the domain is reflecting perfectly with one element in the codomain. Now, here's the trick. You might be wondering, B and D are sharing one element. The thing is, B is reflecting to 2 and D is also reflecting to 2. Okay, so as long as it's just one that is reflecting to, just one element in the codomain, we can say it is correct. In a situation where we have the elements in the domain reflecting to 2 elements in the codomain, then that is not a function. For instance, let's say I have this. Let me give us a good example. Let's say I have this. Let this one be x, and then the function of x reflecting to y. Let this be y. And then I have this should be a, b, C. And this one is 1, 2, 3, 4. Then let's say we have okay, we have A, the element in the domain, reflecting to 1, and the same A in the element of the domain reflecting to 3. Then let's say we have B to 4, C to 2, and all that. Now, this is not a function. It is not a function because A, the element in the domain, is reflecting to 2 elements in the codomain. So it's meant to just reflect to 1 element in the codomain, but it's reflecting to 2 elements in the codomain. So we don't count that as a function. We need to first of all understand how we get these things, understand the range of all these things, so that we can be able to, go further into functions. You clearly understand about functions. In classes, we've treated that. So you will clearly understand about functions and all that. So we see that this one is not a function because one element in the domain is pairing with 2 elements in the codomain. So that one is not it's not a function. So check this one out. Let's say we have a domain as n and we have this as m. So the function of n to reflect m, right? Now we have A, B, C, D. Okay, watch this. And we have 1, 2, 3. So let's say we have this A to 1, B to 2, and C to 3. And then D doesn't have a pair. D, which is an element in the domain, is not paired to anything. So this is not a function. Because, like I said, all elements in the domain must be uniquely paired to an element in the codomain. Now, all elements in the domain can also be paired to the same element in the codomain. But a domain cannot have 2 elements in the codomain. I hope we're getting the entire mapping and all that. It's just ways for us to break it down. Okay. All right. Then let's move further into the types of mapping. Okay, you have a question?
No. I'm sorry.
Okay, all right. So let's move into um, the other parts. Now we have types of mapping. I know we treated this in the last semester, but we need to brush it up again. Yes, Princess.
Okay, thank you so much for hosting this class. Please, I think I missed out your voice on the last part. The one you use N and M. Do you say it's a function or not a function? I didn't get the explanation, please.
No, it is not a function. It's not a function. That's why I put the cancel sign here, the X sign here.
Oh,
Yeah,
okay.
it's not a function. Not a function. Okay. All right. So let's move into the types of function. 1 second. 1 second. Well, we're going to connect all the dots together and then you'll see how they relate. Um, 1 second. Let's see some students trying to join. All right. So let's continue. All right, so we have different types of mapping. The first one is called one-to-one. One-to-one. Okay, so look at this is one-to-one. One-to-one is also known as injective. All right, this is injective. We have injective. The reason I call it one-to-one, or the reason it's called one-to-one, is because everything in the domain is mapped uniquely to something in the codomain. For instance, let's say we have P, right? And P has elements of A, B, C, D. And then we have K, and K has elements of 1, 2, 3, 4, 5. And then A is paired to 1, B reflects to 2, C reflects to 3, D reflects to 4. All these in the domain are uniquely reflecting something in the codomain. So that's a function. This is what we call one-to-one. It's a function of what? P reflecting K. So it is said to be injective. This is injective, or we call it one-to-one, because all elements of P are uniquely paired to elements of K. Okay, that is one-to-one. Forget about this. It's just part of the codomain. But the range, if I should ask, what is the range of this injective, the one we just did? The range of the injective is going to be what? The image of the range is going to be 1, 2, 3, 4, because it's only 1, 2, 3, 4 that is paired. Okay, it's paired to P. So we have one-to-one. We also have what we call onto. We call it the surjective. This is called surjective. This is onto. Call it the surjective. So let's take, for instance, surjective is very, very unique. It's saying that if every element of it is a function if every element of the other side is an image. So it's almost like one-to-one. Okay, check this one out. Let's say we have A, B, C, and here we have 1, 2, 3. So this is paired, this is paired, this is paired. Right? Now this is surjective. See, this is X, and let's say this is Y. So this is surjective because all elements of the codomain are uniquely paired to elements in the domain. Now, this one, the one we had earlier, P and then K, where we had A, B, C, D, and 1, 2, 3, 4, 5. Paired, 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 paired. Now, this one is not surjective. This is not surjective. It is not surjective because all elements of the codomain are not uniquely paired to elements of the domain. But we can say it is what? Injective, one-to-one. So this one is not surjective. This is surjective. Surjective means that all elements of the codomain have a pair in the domain. That is surjective. Injective means all elements, it doesn't care about the codomain. Injective one-to-one just means that all elements of the domain have a pair. Okay, they have a pair in the codomain, uniquely reflecting to a pair in the codomain. Then we also have what we call bijective. Yep, we have what we call bijective. We'll soon get into applications, how we're going to use this to solve functions. Well, let's take it slow. I have what we call bijective. Now, bijective is like, how am I going to put it? It's a combination of both injective and surjective. That's what bijective is. So for bijective, we can say that, let's say we have S and we have T. And then S has elements of A, B, C, and then T has 1, 2, 3. So this mapping for bijective is both injective and surjective. So we can see that all elements of the domain are uniquely paired to elements of the codomain. So this is bijective. Bijective means that it can be both surjective and also injective. It's the combination of both. And with this, we have something we can use to compose functions. Yeah, we have that we can use to compose functions, things we can use to solve for functions or compose functions. We call that the composition of mapping. But before I go into that, let's check back and see if we have any questions. Any questions at all? Yes, Princess.
Okay, please. I really don't get this bijective because it's only reflecting that of subjective. So how is it injective and subjective? Because in the example you give for injective, there is an image that is not reflected, like for the K. So I think since we have bijective and you said is for the two of them, why are they not all reflected?
Right, like I said, thank you, Princess. Like I said, injective means all elements of the domain, all right, are uniquely paired to elements of the codomain. So that means that this can also be injective. This one, because all the elements you're seeing in the domain is uniquely paired to an element of the codomain. It can also be injective and it is surjective. But this can never be surjective. So injective means that all elements in the domain are uniquely paired to elements in the codomain. As long as all the elements in the domain are uniquely paired, it doesn't care about the remaining ones in the codomain. Just its own business is let the elements in the domain be paired to an element in the codomain. That's the business of injective. So even if it appears like this, we can still say this carries injective because all elements in the domain are uniquely paired already to elements in the codomain. Do you understand? But surjective can never be like this, where you have one left out. That's the difference. So this can also be injective and it can be surjective. That's what bijective means. Bijective is the combination of both. Okay. All right. So, all right. Okay, good. Okay, let's go on. So we have the composition of mapping. Don't worry, we're taking it step by step. We'll get into identity and we'll soon get into functions. So let's take our time. So we have the composition. Composition of mapping. So in the composition of mapping, we express it as the function, one of the function and another function. We can compose them to get a mapping. For instance, let's say we have a function. Let's say we have a function S reflecting T. And then we have another function, yeah, G to be another function, T reflecting U. Okay. We can then compose and put everything together and say that we can combine this together. This can be combined together and we'll say it's going to give us a function of H reflecting S to the final bus stop, which is U. So it's like a combination. That's what the composition of mapping is. So when we're dealing with composition of mapping, we're going to touch that when we start solving functions. It means that if I have the function H, the function of X with H, and I'm given an equation like this, the function of X. So what this means is I will first of all find the function of x, fx, then I use what I get to find the function of gx before I can get my final answer as hx. Don't worry, relax, we'll deal with it. So this means finding the function of fx first, then finding the function of g second, before I can arrive at h. That's what it means. So if I put out the composition properly, it's going to look like this. It's going to look like this. So this is the function of f. This is the function of g. And that's the function of h. So we're composing, meaning that it's a composition. You can see f, the function of f is s reflecting t, and the function of g is t reflecting u, and the function of h is s reflecting u. The combination of all of them together. That's what it means. So that's just a brief about mapping and functions. Before we go into start looking for range or calculating range, understanding how to find range, so I need to know if we're clear on this, so we can start the other and then dive into domains. Any questions? All right, so we're good. Okay, let's go on. Now, let us know how to locate domain and also locate codomain. So let's consider this. Okay. Let's consider this. Let's say we have A with an elements of has P, Q, R, S, T. And then we have B, elements of 1, 2, and 3. P reflects to 1, Q reflects to 1. R reflects to 2, S reflects to 3, T also reflects to 3. It goes this way. And so if you look at this, it is asking, what are the elements of the codomain? We just want to get a brief understanding if we know what it is. What are the elements of the codomain?
1, 2, 3, right?
Yes, correct. 1, 2, 3. The elements of the codomain are 1, 2, and 3. Now, what if we have something like this? And it asks us, what are the elements of the codomain?
1, 2, 3, 4.
1, 2, 3, 4. Okay, good. What about the image? Or what's the range of the mapping?
1, 2. 1, 2, 3.
1, 2, 3. Thank you. All right. Yeah, we're good. We're good. That's good. That's good. That's good. Okay. So I think we already have a clear understanding about this mapping and all that. Let's now push it into domain of functions. Let's go further. Let's drive. So let's say, okay, All right, so this question says here that find, let's say, find the domain, of, we have a function, the function of x, which reflects x squared plus 6. And it now tells us if the range, it's giving us a range now, if the range of the function of f is, range of the function is 6, 7, 10, 15. Now tells us if the range of f is 6, 7, 10, and 15, wants us to find the domain. So in situations like this, what you're going to do is you're going to reverse the process, because here now they're already giving you the range and they're telling you to find this guy, the domain. So it's going to be a reverse case. That's what we're going to do. We're going to reverse the entire process. So what this becomes now would be, we find the range. The range says if the range of f is 6, 7, so we find it like this. We say, okay, for range 6, that's the sweet part of functions, just insert. Okay, so for range 6, it is telling us that the function x is reflecting x squared plus 6, right? So it is already giving us a range, which means it is reflecting that part. So it is telling us that x squared plus 6, all right, is equal to 6. That is for range 6. Then we calculate it so that we can get our domain. What is reflecting to 6? That's what it means. Okay, what is reflecting to 6? So for range 6, that means this is equal to 6. That's what's reflecting to this. So, you know, when we're dealing with the range, we're dealing with the mapping, it's going to be something like this. Here now we say it is x reflecting to x squared plus 6. That's what it means. So they're asking us that, okay, we're giving this one as the function. What is the domain? What's the value of the domain? That's what they're saying. Okay, and that's what we're looking for. So what we're going to do is, they already gave us the range. Okay, they gave us the range. They said that the range is, what that means, what is meant to be here is now 6. Another one that's meant to be here is 7. The other one that's meant to be here is what? They said 6, 7, 10. The other one that's meant to be here is 15. So they've given us range already. They want us to start looking for the domain. What are the things that are reflecting this? That's what they need us. They want us to find the domain. And that's what we're going to look for. So I just drew all that to give us brief understanding about what we're doing. So it means that for the range of 6, we'll just equate the equation to 6. So we have x squared plus 6 equals 6. We move 6 to the other side because we want to make x squared. We're looking for x, right? So it becomes 6 minus 6, and that is equal to 0. And if you find the square root of that, it is still 0. Okay, so x equals 0. When we try to find the square root, is equal to 0. Now for the range of 7, we continue now. For the range of 7, we go on. So we have 0 as the first one, right? For the range of 7, so that is x squared plus 6 equals 7. And then we move this guy here. It becomes x squared equals 7 minus 6. And then x squared equals 1. We'll try to remove square. Anytime you're removing square, all you need to do is just square root both sides. So we root both sides. Introducing a root, you have a plus or minus. Please don't forget. And this is 1. Whenever you're introducing a root with a valid number, okay, you have a plus or minus. That's the meaning. So we have a plus or minus. And so what this means is x equals plus or minus the square root of 1. And for that, it means that square root of 1 is 1, right? So this means x is equal to 1 plus 1 or negative 1. So we can say x is equal to 1 or negative 1, or negative 1 and 1. For the range of 10, so someone should help us with range of 10, and then another person should help us with a range of 15. So let's find that part. Range of 10 and range of 15. Anybody?
Range of 10 is plus minus
I
2.
think that
Plus or minus 2 for range of 10.
Correct. Range of 10 is plus or minus 2. And then range of 15.
Okay, range of 15 is plus or minus 3.
Plus or minus 3. That is correct. Okay. All right. So what we're going to do now is we're going to arrange everything here. 1 second. I think some people just they just registered again. Let me see. 1. Okay. So we have plus or minus 3. So what we're going to do is we're having two values. So the domain, we have a domain set. The domain set, we have a domain set. The domain set is going to be, so we're going to start from the negative down to the positive, right? So it means that we're having the domain set to be, we have -3, -2, -1, we have 0, okay? And then, okay, let me just write down this ones first. -2, then we have 0, we have 1, we have 2, and we have 3. So that is the domain set. So the domain here, we're having two domains. The domain here would be, we have the set of the positive domain, which is 0, 1, 2, 3, or we have our negative domain, which is -3, -2, -1, and then 0. Yeah. Okay. All right. So that's how we get a domain when we have range. That's how we get a domain when we have range. Now, we found our domain from the range. What if we want to find range? And we're already given like the domain, and we're trying to find range. So when we're looking for domain, we do the reverse. Okay, we do the reverse. When we're looking for range, it's quite different. We just slot in the function. Okay, so before we try to do that, do we have any questions? Okay, so we're good. Now, there are different parts. We're heading further. We'll soon get into the value of a function. We get into composition of function. Don't worry. Once we're done with this, it will be pure proof that we now understand functions and we can deal with functions anytime. Then the rest will just look like, child's play and all that. So let's look at this. Then we'll do the questions and the elements that deals with functions. By the way, she only asked in the entire test from 1 to 41. They asked 21 questions in test 1. I don't know why. When the entire test, there were only 5 to 6 questions under these functions. Most of them were calculus. Well, hey, can't tell what exam will bring, right? So let's say, let the function, this one is another one now. So let the function of W reflecting R, let it be defined. Sorry, I don't have strength to grab that keyboard and start typing. Let me just write. Let it be defined by, so let it be defined by f, which is x squared minus x minus 2. Okay. So let's have that. The function f to be defined as W reflecting R, and then that's the definition, x squared minus x minus 2. You can see that is looking like a quadratic equation already. So function can come in any form. We're already seeing a quadratic inside the function. Can come as any form. So let's put it this way, where we have W have the values of -1, 0, have -1, 0, 2, 5, and 11. And R, what R means is the set of real numbers, okay? The set of real numbers. Now asks us find the range. That's the question now. Find the range. All right, so we already have this, okay? This is what we have. We have W to be -1, 0, 2, 5, 11. And it wants us to find the range. So what are we to find here is the range, which is also the image. So we're looking for the range of f, right? So we have the function definition to be this. The function definition is already given in the question. We have fx to be equal to x squared minus x minus 2. That's what it was given there. And then he gave us the domain. He already told us what W represents. So that's the domain. So we're looking at the range that is going to be reflected in the set of real numbers. Okay, so it must be the set of real numbers. So what we're going to do is we're just going to insert. Since we already have the domain, we just insert. First one is f of -1. So we insert that and then we start solving. So the function of -1, we just put anywhere you see x, you impute -1 and then we solve. And then -2, right? And we keep going like that. The other one is going to be the function of 0. So we have f to the function of 0. So that's going to be 0 squared minus 0 minus 2. And then we have the function of, the third part will be the function of 2, right? So that is 2 squared minus 2 minus 2. And it keeps going like that. It says -1, 0, 2. So we have the function of 5. All right, so can we solve this and tell us what are the values we're going to get? Then we have the function of 5 as well. Then we have the function of 11. Function of 11. Yes, Princess.
Please, I'm sorry, but I'm actually lost in this one. I don't understand what you did.
Oh, okay. So here we're already given function, right? We're already given the domain. The domain is the W. The W says is -1, 0, 2, 5, 11. That's the domain. Because if you check the function, it says W reflecting to R. Okay, so we have the function of W reflecting to R. So like this is the domain and this should be the codomain, right? And then we're looking for the range. So those are the numbers that are perfectly reflecting the domain, right? So we're looking for the range. Okay, so it means that since we're given the domain, the function, we just insert -1 into all the places where we have x. So that this is the definition of the function. The function of x is reading x squared minus x minus 2. So they gave us that, the definition here. So wherever we see x, we impute the domain values inside of it. So for the first one, I imputed -1 into it. And that is wherever I see x, I impute -1, right? So that is -1 square minus -1 and then minus 2. So if I should solve this, -1 is 1, minus minus is +1, and then this is minus 2. So this one is going to give me 0. It means that my first range, okay, it means that one of the range is paired to 0. Okay, then I continue here. So this one is going to give me -2. So I'm getting the range like that. So that's why I said we can, okay, let's find the one for 2, 5, and 11. So what will be the values? Yes, Samuel. 0, -2. Yes. What about that for 2, that for 5, and that for 11? Okay, okay, you said for the one of 1, Regina says 108. That is correct. So for 11, right? 108. So we have 108 here. Okay, and for 5, Samuel says 18. So 18, yes, we have 18 here. And that is correct. So our required set, um, is going to be for the range. That's going to be what we have. We're going to start with the, in a number line, it's left to right. So that's the negative to the positive, right? The middle is 0. The midline is 0. So it's left to right. So we're going to start with -2. So that'll be -2, 0, 18, 108. Right? So I have -2, 0, 18, and 108. That's our range. So we found the range of f. Okay. Do we have any questions? Okay, we're good. All right. Thank you guys. Okay, so now let's touch this part. This one says that says here says that if the domain of f is reflected to x squared minus 2 and is defined as -2, -1, 0, and 1. Okay, it wants us to find its range. So I guess we now understand this kind of function. So let's try to find a range and see. All right, so can we find a range? Okay. Okay. Oh, well, was okay. Let's stop. All right. So we have for -2. For -2, we have 2. For -1, we have -1. Okay. Okay. Let's keep going. All right. What else do we have? Okay, Moses, -2 and -1 as the final ones. All right. So yes, Summer got 2 and -1. Moses got -2 and -1. So Moses, the -2, is it for the function of what? Function of what and what?
It's for the function of
Okay,
0,
function of 0 and function of which other one? 1. All
1,
right.
and
All right. So So this is function of 0 and this function of 1. All right, so yes. Now, so for the function of -2, somehow, function of -1, somehow, function of 0, Moses, and function of 1, Moses. So this is 2. This is -1 from Samuel. This is -2. This is -2. And this is -1. So if you check it properly, you can see that this range is having two different, the same, yeah. Yes, Princess.
Okay, I got -6, so in that function of -2.
I also got -6 too.
Then the function of -1, I got -3.
And -3 also.
All right, let's solve it together then. Let's break it down together. All right, so for the first one now, the first one says -2. So for -2, I'm just going to impute it into this equation. I will impute it into the equation. So it says that the function of -2 is, this one says the definition of x² - 2. So function of -2, that means we have -2 square, then -2. So now -2 square is 4. -2, that is 2. Okay. The other one says the function of -1. So we say -1 square -2, right? So -1 is 1. -1 square is 1. Then -2, that is -1. See that? The other one is the function of 0. Okay, yes.
Okay, so what this means is that anything negative that is squared becomes positive, right?
Please, can I answer her question?
So it means that, oh yeah, sorry, I was muted. I thought I was even explaining. Yes, you can go ahead.
Yeah, what she's actually doing, she's summing all of them together. That's why she's getting that answer. What she did -2 square -2. She added all of them together instead of just -1 square getting your answer, then minusing it by 2. She did all of them the same.
Yeah, I can see. Could be
I
like
think
your
that's
function in the calculator or something.
Is the calculator?
Yeah, it's the calculator.
They don't sum all together.
So we know minus times minus is plus, that's positive, and 2 times 2 is 4. Minus times minus is plus, that's positive, and 1 times 1 is 1. Okay. So, yes, all yours. Your hands up. Thank you, Moses. Okay, all yours. All right, so do we now understand how we got the answers, Princess?
Yes, thank you.
Okay, you're welcome, and thank you, Moses, as well. All right, so for putting in the sets, now we can, if we check this properly, okay, let's just focus here. If you check this properly, you have -1 and -1. So that is like an element. Remember when we're dealing with set the last time? Okay, when we dealt with set, we said that set. You're welcome. We said that set actually, if you have the same element, it is just counted as one. So if we're going to be looking for the range here, what this means is that if you look at this, yeah, if you look at this, so this is what it means. It just means that one of the elements in the domain is paired to the same element in the codomain. B is paired to 2, D is paired to 2. That's a function, right? So, and that's exactly what's happening here. So if we're going to write the range, our range is going to be, we're going to have -2, -1, okay, and 2. This is going to be the range, the set of the range. Yes, Chris.
Good afternoon. Can you hear
Yes,
me?
yes, can you hear you, boss?
Okay. I'm really sorry. I think I joined very late, so I'm kind of lost somehow. If it's possible, that's if it's possible. If it's okay, then maybe a small summary, like a run through, will be fine for me. But if it's not okay, then I will just have to manage and we
All
continue.
right. All right. Where did you join? Which part were we talking about? Which side? So I know where to go back.
About the, I just said the range and the, not quite long ago. I just joined, I think.
Oh, okay. So that's an hour journey. But anyways, we're dealing with mapping. I'm just going to run a brief. And in mapping, we have a domain and then we have a codomain, right? So we say that in a domain, we have elements, and in a codomain, we have elements. Every element of a domain is uniquely paired to an element in the codomain. That makes it a function. So it runs as a function. And if you look at this P and K, you see ABCD is uniquely paired to an element in the codomain, which is K, 1, 2, 3, and 4. Don't worry about 5. As long as it is uniquely paired in to an element in the codomain, we consider that as a function. So, and then we have the function. We have that the codomain has elements of 1, 2, 3, and 5, 1, 2, 3, 4, 5. But the range is actually the image. Like when you look at a mirror, you have a reflection of your image, right? So the range is the image. It's what perfectly or uniquely pairs with all the elements in the domain. A pairs with 1, B pairs with 2, C to 3, and D to 4. So it means that the range is 1, 2, 3, 4. Those are the only elements that pairs with an element in the domain. Then we went further to look at another example. We said a function of H reflecting P, like the function of H looking at the mirror to P, right? And H has A, B, C, D as its elements. P has just 1, 2, 3. We said A reflects to 1, B reflects to 2, C reflects to 3, and D also reflects to the same 2. So what we're saying is this is also a function. Why? Because all elements in the domain reflects perfectly or uniquely to an element in the codomain. So B is reflecting to 2, and D is also reflecting to 2, meaning they are having the same reflection. It's just that the element itself in the codomain, in the domain, is reflecting. But that is a function. But when it comes to an example like this, A is reflecting to 1, and the same A in the domain is reflecting to 3. Now, that is not a function. We don't consider that as a function because, we're having double reflections here. It's meant to just be the element in the domain reflecting to something in the codomain, right? So
Okay.
that's not a function. Now, when you look at this, you can also see here N is in the domain, and we have a codomain M. We have one element that is not paired, which is D. As long as the element is not paired, it's not a function. The element in the domain must be paired. We don't really care about the codomain. The codomain could just be the set, right? We just want to ensure that the elements in the domain are uniquely paired to elements in the codomain. So like they have to be paired. You get what I'm saying? So
All of
D is not paired, so this is not a function. Yes, you say?
Okay, so even if it's just one that is not paired, that means the entire domain is not a function.
It's not a function. No. This entire thing, F, the function of M reflecting M is not correct. It's not a function. We don't consider that as a function. Then we went into types of mapping. We said we have one-to-one mapping. One-to-one mapping simply means that all elements of the domain are uniquely paired to elements of the codomain. Yes, Rafiat?
Thank you. Please, I don't know if you could come again with the statement that you just made that something is not a function. Thank you.
All right. So I said here that in the domain, A is reflecting to the codomain, A is reflecting to 1, and A is also reflecting to 3. Now, that means that is not a function because we have an element in the domain reflecting to 2. It's having 2 reflections. So we don't consider that as a function. When you look at the mirror, except that mirror is broken, you can be having double or triple reflections. But a perfect mirror, you have just one reflection, right? So it means that A reflecting to 1 and 3 at the same time does not consider, we don't make this one a domain. This is not a function. It's a wrong thing. It's not a function. A function says that elements in the domain, which is here, must be uniquely, this is the domain, right? So it must be uniquely paired to elements in the codomain. So if you consider this now, B is paired to 2 or reflects to, and D also reflects to. They are all elements in the domain, and they are paired to at least an element in the codomain. Okay, so that works. So D, maybe what if B and D are twins? Okay, or they are looking at the mirror from different angles, the same mirror, right? So they're going to reflect. What if the mirror has 2 sides? So they're going to reflect. So all elements in the domain are uniquely paired to elements in the codomain. Now the situation here is quite different. This one is saying that the domain does not have, it has double pairs. Incorrect. And this one here, we see that in the domain, an element is not paired at all to nothing. So if an element is not paired in the domain, it's not a function as well. It's not considered a function at all. So we don't take these two, we don't take them as functions. This and this. These ones are not functions at all. We cross them out. So
Sorry.
Yeah.
So if I get you correctly, if two different elements are paired to one domain, it means that they are not, it's not a function, right?
Yes. If 2 elements in the codomain are paired to one element in the domain, that means the domain is reflecting 2 elements. It's not a function.
Okay, thank you.
Okay, sorry.
Welcome.
Can I say something?
Yeah.
Okay, so I think I understand the domain
Yes.
as the input, right? The input, the domain.
Yes. Yeah.
Then the range as the output. I'm not sure about the core domain.
The codomain is where it's from the codomain you get the range. So you need to understand the codomain. It's from the codomain. Look at this example. Look at this first one. You can see the codomain has elements of 1, 2, 3, 4, and 5. Do you see that? So
Okay.
the elements, but the range is just 1, 2, 3, and 4. So the range actually reflects the things that you need here. The 1, 2, 3, 4, 5. So the codomain contains all the elements. The range now is the one that perfectly, uniquely brings out the outputs of the one in the domain, or the one that reflects perfectly with the one in the domain. You see that?
All right. Thank you.
Mm-hmm. You're welcome. Then we have injective. Injective, these are the types of mapping. We have injective. I want us to understand it first so that we can go into, because this gives us like a drive into function. And from there, you have deep understanding. So we now have injective. Look at the injective. This is one-to-one. We call it one-to-one. What injective means is all elements in the domain must be uniquely paired to an element in the codomain. That means all elements in the domain must have an output in the codomain. They must have a range. That is what injective is saying. If you see here, we have 5. It doesn't really matter. As long as the elements in the domain are paired, injective doesn't care. So it counts it as a one-to-one. We have another type of mapping, which is called surjective. Surjective means that all elements in the domain are uniquely paired to an element in the codomain, and they do not have any other element, meaning that in the codomain, there is nothing left out. That is surjective. So we can count this one as injective as well, because remember, injective says that what? All elements in the domain must be paired to an element in the codomain, right? So if injective is saying that, that can be counted as injective. But this cannot be counted as surjective because we have something left out. So in surjective, something is left out. If something is left out in the codomain, it's not surjective. It's not called an onto mapping. Okay, that is injective. But this is surjective. Surjective has both the domain and the codomain uniquely paired. That is surjective.
Okay.
Then we then have bijective. Bijective is the combination of both surjective and injective. So in bijective, we say that all elements of the domain are uniquely paired to elements of the codomain, and that can be surjective, that can also be injective. So let me just say bijective is almost twin brothers to surjective, but it's a combination. You can find injective in surjective. You can find injective in this guy, surjective. Well, injective has its own unique feature. It doesn't really give a damn about what other elements are outside. So if like 3 other elements are left out here, let's say we have 4, 5, 6, we only count this as injective. That is what injective is going to do. We only count it as injective. It doesn't really bother about that. As long as these guys are uniquely paired, that's its own. It's a one-to-one. It's a win for it. So, but subjective, they care about that. They care about all that. So you can find injective in. Okay. Then we went into composition of mapping. We talked about if we have a function S reflecting T and I have a function of G of T reflecting U. We say the combination of both is like you saying that S is reflecting to U. What that means is to get the function of H, we say we first find the function G to the function of X means finding the function of F. Then we find the function of G to get to the function of H. You first find the function of F, then you find the function of G. Don't worry, we're going to do examples on that. And then we get to the function of H. That's what it means. And then, okay, so this is it. This is like the graphical map. We have the function of F, and then we have the function of G, okay, which the combination of the function of H. Then we went into this. So I asked a question here. I said that what will be the range? If you look at this properly, what do you think is the range? Or okay, let me ask you, Chris, what are the elements here of the codomain? What are the elements of the codomain? So if you look at that, you have this. So what are the elements of that codomain?
I think yeah, 1 to 4.
Sorry, did you say something?
Yeah, can you hear me?
Yes, I can hear you now.
Okay, I said 1 to 4.
All right, correct. 1, 2, 3, 4. What about a range?
The PQR.
Okay, PQRST is the domain. You got the codomain correct. What about the range?
The range.
Output, the range, yeah.
So if we say the codomain, the main domain is paired with the codomain. So from this, you can say that the A, I can say. Okay, that's the 1 to 4.
Yes, keep going. So yeah, you were saying?
I said the PQRST is the domain.
Yeah.
While the 1 to 4 is the codomain, more like the output,
Yes.
right?
Yeah.
Okay, then I think I'm not sure about the range now. Or is it still the
Okay, the range is 1, 2, 3. Remember, the range is the one that is uniquely paired. That's why I was showing you this. Okay. Yeah, that's why I was showing you this here. The ones that are uniquely paired. If you check this one, we said that 1, 2, 3, 4 are uniquely paired to the ones in the domain. So that's what the range is. You see that?
okay?
Yeah, that's why I went back to show you. So that is like what the ranges. The range comprises of the ones that are uniquely paired. As long as it's uniquely paired, it's the range. In here, we have a range of 1, 2, 3, 4 because it's uniquely paired. But we have a codomain here as 1, 2, 3, 4, 5. But the range, that is the perfect output for the domain, is 1, 2, 3, 4. You see that?
Yes, sir.
Okay, so then we moved into how to look for domain. So this question gave us a range, and then we're looking for the domain from the range. So we said that if the range of f is, we have a function. It says find the domain of the function x if x reflects to x squared plus t. So it wants us to find the domain. If the range of f is 6, 7, 10, 15. So when you're given the range and you're asked to find the domain, what you're going to do is you calculate everything for the range. So if I should explain this in mapping, it means that x is reflecting, x is the domain, and it is reflecting x squared plus 6. And then the question said that, okay, if the value of this definition is, the first part is 6, the other one is 7, the other one is 10, the other one is 15. It wants us to find the values inside here, the domain, that are paired. So what we're going to do is we then equate. If the range, since we're giving range, we just equate the definition, which is x squared plus 6. We equate it to 6. We solve for x. We go again, equate it to 7. We solve for x. We equate to 10. The range that was given, we solve for x. We equate to 15, and we solve for x. All the values that we get, we list them out. Some are positive, some are negative. Why? Whenever you're looking for the square, we have x squared equals 1, and we're trying to just find x. You know, you're going to square root both sides, right? So that you can get x. That's what you do. Like when you say y squared equals 25, and you're trying to just find y. To make y subject of formula, you square root both sides. Y cancels, the square root cancels the square, and y is equal to 5. But in functions or in quadratic equations, you always introduce our plus or minus because we have a number line. So whenever you're putting out a square root, your plus or minus sign must come out. It must exist. Your plus or minus sign. And that's what we did here. That's why we're having a positive and negative. If you check here, you see that that was added. So when we wanted to look for, just make x subject of formula, we wanted to get rid of the square, we have to square root both sides. And to square root both sides, we introduce the plus or minus to the square root of 1. So we have x equals plus or minus square root of 1. Square root of 1 is 1, so we have plus or minus 1. That's why we have plus 1 or negative 1. We did the same thing for when range is equal to 10, we got plus or minus 2. That is plus 2 or negative 2. Did the same thing when range is equal to 15, we got plus or minus 3. That is plus 3 or negative 3.
Please, I'm sorry. I didn't understand this plus or minus thing. I'm so sorry. The square root part. Sorry.
Yeah, for the square root. So, Rafiat, let's say we have something like this. Let's say we have x squared equals, going to give us 25. Let's say we have a squared equals 36. We've arrived at this equation, but we're looking for x, and here we're looking for just a. Let's take the first example. We're looking for x. To get rid of the square, this is algebra now, like pure math. To get rid of square, okay, foundational math, what you do is you find the square root of both sides of the equation. Square root cancels square. Just like when you're dealing with 5a equals 10, and to get rid of the 5, because it's multiplied by 5, you divide both sides by 5, right? And then a equals 2. But for square root, for square, you do the opposite. That is the square root. If it is cube root, you find the cube root of both sides. But since it is square, we're dealing with just square root. So square root will always cancel the square, and then x equals 5. Same thing with this. A squared equals 36. What we do is, we do what? To remove that square, that little guy, we find the square root of both sides. So square root would cancel the square, and a now is equal to the square root of 36 is 6. 6 times 6 will give us 36, right? And 5 times 5 will give us 25. So those are perfect squares. So the square root means that single number. Now, in algebra or quadratic equation or functions, we always introduce a plus or minus sign behind when you're looking for the square root. So this means plus or minus 5. The reason why we're introducing a plus or minus sign is because we have a number line. If you check your graph, you always have an origin. One part of the graph is negative, another part of the graph is positive, meaning that x have a range of values of negative numbers, x also have a range of values of positive numbers. So when you're solving for square root, it means you're going to have from this part and this part. That's why we're putting the plus or minus sign, because the equation or the function is trying to know that, okay, there is a possibility that we have two answers. Okay, so yeah, that's why we introduce, when we're solving for the square root, we always introduce the plus or minus sign, and then we have x equals +5 or -5. If you're using a calculator, what you're going to get is just 5. But because you have the knowledge of finding functions, you know that you need to introduce a plus or minus. That is +5 or -5. Same thing goes here. So this is, we introduce this. So we have +6 or -6 as our answer.
So at every point in time, we need to introduce the plus or minus to get our answer. Is that what you're saying?
When you introduce the square root, when square root is being introduced.
Okay. Thank you very much.
You're welcome. So, and then we got our domain. So from the range, we did the reverse of the equation and we got the domain. And then we moved to this part where we said, okay, now we have the domain. Let's find the range. So this is the easiest part, where you just have to slot in the function. You slot in the function and then you work with it. So we said f to the function, x squared minus x minus 2. And then we have the w. This one says, let the function f be w reflecting r. R is going to be the set of real numbers, right? So w reflecting r. So that means w is our domain and r is our codomain, right? So w reflecting r, and then it is defined by x squared minus x minus 2, meaning that function is x squared minus x minus 2. And then it gave us the value of the domain. It says that where w equals -1, 0, 2, 5, and 11. You have a question, Chris? Okay. Okay, I didn't hear, but okay. Then it says we should find the range. Okay, so we went ahead to look for the range, and then that's when we got this. So to find the range, it says that we have f of x. So to find the range, all we need to do is slot in -1, 0, 2, 5, 11, and that's what we did here into the definition. So f to the function of -1, that's why we have -1 square according to the equation, right? So wherever you see x, you impute that. So that means -1 square minus -1 minus 2. -1 square is 1. -1 is +1, because minus times minus is plus, so you have +1, and then -2. So, and that's going to give us what? 0. Then we go ahead, we slot in 0. We have 0 squared minus 0 minus 2. So we just slot in the answers and then we have our values. Okay. So,
Sorry, can I see the question again?
Yeah, this is the question.
Okay, let the function be.
So I'm sorry, in this question, there is square root there, but when you're solving for it, you didn't square both sides. I don't know.
Yeah, we didn't square both sides because we're not looking for x here. We already have the function, right? We already have the domain. So instead of looking for x, we just substitute x as -1 according to what is given to us in the domain. So wherever we see x, we just impute. If you look at it, we have -1, we have 0, we have 2, we imputed 5, we imputed 11. So it means that we just slot in x, the value of -1, we put it here, -1, -1. So wherever we see x, we impute -1. When we had 0, the value of 0, we just slot it there. So we have 0 square minus 0 minus 2 instead of x square minus x minus 2. So when it was -1, we had -1 square minus -1 minus 2. So when it is 5, it will be what? 5 square minus 5 minus 2. When it's 11, it will be what? Instead of x squared, it will be 11 squared minus 11 minus 2. And then we'll be getting our values. Then we get
Okay.
our range set.
Okay, so if you were to plot this, that means the values given is already the input, which the x axis. While you have to find the y axis, then you can plot your graph if you were to plot, right?
This is on a number line as the function. The reason is we already have our domain, which is -1, 0, 1, and 1, 2, 5, and 11. So this is our range of values. This is the output. And they are all on a number line: -2, 0, 18, 108. As in situations like this, where if you keep on having numbers, like let's say we keep on having positive numbers, we can now say infinity. And if we keep on having negative numbers, we can say negative infinity. That is negative numbers on the number line. And this one means positive numbers on the number line. So it keeps going on and on and on like that. That's the meaning.
Okay, so
Okay.
I was like asking if you are to represent this on the number line. So the values we got now, based on our own calculations and what we substituted, is going to be the y axis, right? While the given value, that's the -1, the 0, 2, 5, 11, is going to be the x axis, being the input values.
Oh, you're talking about plotting the domain against the...
Yes.
Okay. So the domain is the x-axis, and the codomain or the range is our y-axis, if you're going to plot it on your graph. So here now we're going to have the value of -2. We'll be having 0 as well. We'll be having 18. We'll be having 108. However, we used x to find what these values are, what the output are. So the line might actually be, a bit. So when we have -1, let's say for the x-axis. Okay, let me do this somewhere else. 1 second. So for your question now, when you have, let's say we have -1, right? And for -1, we're having it at 0 if we check the values properly. So for -1, we have 0. For 0, we have -2. So let's say -2 is here. Okay, for 0, we have -2. For 2, okay, when x is 2, we're having what? We're having 0. So this is 2, this is 0. For 5, we're having 18. So let's say 18 is at this part here. We're having 18. This is what happens when you plot it against x-axis, y-axis. And then for 11, we're having 108. And for 11, we're having 108. So 108 is like infinity to the y. So it's going to be around here. So if we plot it against the y-axis, this is the reason why they represent it on a number line. If we plot it against the y-axis, we're going to be having something like this. You see that? And that is questionable to a function. So when we're expressing our range values are always on the number line on the x-axis. That's why we always represent it this way. We have -2 as our range, we have 0, we have 18, and we have 108. So we're going to express it on just a number line as, okay, from -2 down to 108. So we have -2 as a range. Inside there, we can see 0. Inside there, we can see 18. And inside there, we can get 108. So it's represented on the number line. If it's the y-axis, or you're representing it on the y-axis or plotting the y-axis, you're not getting the function. Okay, because if you draw the line or use the vertical line test, you're getting something like this. right? It's already touching two parts of the line. Doesn't give us that as a function. So I hope you're getting the scope.
Yeah, thank you.
Okay. So let me put this. All right. So then we move to this part. Yeah, this was the other question. We said if the domain is the domain of f(x) is reflecting x squared minus 2, and we have the domain to be -2, -1, 0, and 1. It says find the range, and that's what we got. We found the range. So that's what we're doing. So Moses and Samuel, they just helped us with that. They inserted -2, 0, -1, 0, and 1. Yes, all yours. You have a question? Oh, yes.
Okay, so the -2 is dependent on that line. That's that number line.
Yeah, the -2 is on the number line. They're all on the number line.
Okay, no problem.
All right. So this one here, we have -2, negative. You can see -1 and -1. So we just put it as -1. And then what else we have? We have 2. I think that should be our range set. Yeah, that should be the range set. So if we're going to arrange this in a mapping format, when I arrange it in a mapping format, we say that we're giving what? -2, we're giving -1, we're giving 0, and we're giving 1, right? Once I arrange it in a mapping format, yeah, we have -2, we have -1, we have 2. So when it is -2, -2 is paired to 2, -1 is paired to -1, right? Then what else do we have? 0 is paired to -2 uniquely, and 1 is paired to -1. So this is a function. It's correct, because everything in the domain is uniquely paired to an element in the codomain. And that's the range. -2, -1, and 2. So
did you
just
skip 1 from the range?
we never got 1 when we solved for range.
Like, I
What
mean
we had was
-1, sorry.
we already
2
have
negative.
-1. Yes, we have 2 -1, but that's why I said that -1 is counted as 1, just like you're dealing with sets.
Okay,
You
so
count
if
that
there's
as
any
1 element.
duplicates, it's a mesh.
It just, yeah, because of this. Remember when we had this, it's still a function. So this one means that there were duplicates. There were 2 and 2. They paired it as 1.
Okay, I get now.
So that's the meaning of this. So I just represented it in a map, so we follow through what we've been doing since.
Thank you.
All right, you're welcome. So let's move further. So we're going to move further into we're getting into the value of a function now, and that's good progress. That's good progress. We'll also finish the entire basic to composition of a function. So before we go on, do we have any questions? Yes, Rafiat.
I'm sorry, but please, I don't understand this one that you just made. The -2, -1. You didn't merge 0 with anything, so I'm kind of confused.
0
Okay.
is merged with -2.
Okay. Right. I don't think. Okay, so -2 is merged to 2. -1 is merged to.
-1.
Okay. Okay, it's merged to -1. Then it's 0 to -2. Then 1 is not merged to anything, right?
-1 again.
Oh, okay. I get it. Thank you.
Why are you always sorry when you want to ask questions? Why are you sorry? Because Nigeria is hot. You feel everybody's angry, Abby?
Right.
All right, let's go further. Let's let's move on. Okay, so this one is, yeah. So that is just getting domain and range of that. So we already know if something is surjective. We already know if it is injective and all that. Okay, so that is good. But how do we determine if an equation is surjective or if it is surjective or injective? So check this out now. Let's say we have this one. Let's determine if it's injective or surjective. You know, let's say we have the function r, and r reflects r, which is defined as the function of x to 2x plus 1. Okay, and then um let's say we have the function r to reflect r, and we have this one to the function of x to x squared plus 2 over x plus 1. So can we determine if this is injective or if it is surjective? That's the question. Can we determine if it is injective or if it is surjective? All right, so let's go ahead. So first of all, let me see. One second. I think a student is trying to join. So first of all, we say that if x, we have fx to read 2x plus 1. So what you're going to do is we want to know if it is surjective. We want to know if all the elements in the domain are paired to the elements in the codomain. So let it be that since we're saying that r is the function of f is r to reflect r, right? So we can as well just say let A be defined as B belonging to R. So what this means is I'm saying that if I have a function of A, it should be equal to the function of B, meaning it should be uniquely paired to that of B. Injectivity or surjectivity states that all elements in the domain are uniquely paired to an element in the codomain. That's what it means. So let's see if it is injective. If it's injective, both sides are meant to give me almost the same thing. All right, if it is injective. So if we have the function of A, the equation is the function of x to read 2x plus 1. That's the equation, right? So we just put it here. We're testing now. So this is going to read 2a plus 1 equals 2b plus 1. So we bring out 2a and 2b, right? So if we say 2a is equal to 2b, we can say a is equal to b, hence the function is injective. The function is injective. So if you're going to show, this is how you actually show for. Oh, 1 second, I need to plug this. 1 second, guys. Yeah, battery was out. I had to plug it. Okay. So let's say we're having We want to know if it is surjective. So we just got the one for injective, right? So we equated both of them together. We created two functions, and we checked if it's going to be the same thing, or if it's going to be equal to each other. So for surjectivity, what we're going to do is we're going to equate it to y. So we say to get surjectivity, draw a straight line. For surjectivity, or for test of to get surjectivity, we say that let the function of x be equal to y. Then we equate 2x plus 1 is equal to y. Right? And then we solve for x. So we then solve for x. So we solve for x, we say this becomes 2x equals y minus 1. Move 1 to this side, becomes minus 1. And then we divide by 2. So we divide both sides by 2. So we're solving for x, right? So x is equal to y minus 1, right? And then we check, okay, if we make y, because they said r, right? So real numbers, it belongs to real numbers. So this is real numbers. So let's check. Y equals 1. If y is equal to 1, this means x will be equal to 1 over 2, 1 minus 1. And then this is x equals, this becomes half times 0, and that is 0. So if it's equal to 0, it's a real number. 0 actually belongs to real numbers. So it's a real number. So that means this is surjective. So it is both injective and it is both surjective. It is injective and surjective. I think I just was speaking Japanese here. All right, you can ask your question.
So, sorry. Well, for the previous one we just solved, the previous one before this one, is that subjective or injective?
Okay, this is injective. The one where we equated the two functions.
No, not this one. Like the other one
Which other one?
before this whole new one, this whole question.
Oh, this one's here. We're looking for the range.
Okay, but how would you categorize those one? If you to
Oh, if we're to find if it's injective or surjective, we just equate. That's what we're doing here. We just equate it to each other to see if it's going to be injected, or we equate it to y to see if it's going to be injected. We have to start solving the equation over again, or putting a function over again. But
okay,
if I should look at this one, it belongs to real numbers. So this one actually belongs to real numbers. So I'll say they are injective and surjective because they both belong to real numbers, except they are carrying things like that we cannot find the real numbers, things like square root of 2, or things like you know, when we have logarithm, we introduce logarithm now and all that. So for instance, let's say we are getting the log of a negative number. That one is not surjective. So we cannot say things like that will not give us. You understand?
all right. Thank you.
Yes, princess.
Please, I don't understand this one at all.
Okay, so from which part?
This one you said talking about solving for whether it's subjective or injective. Like I don't get it.
Okay. All right. So this is it. When you're solving for injective, you create two functions. So okay, so this is it. Let me use this fresh part. So we're solving for the function was what? The function was 2x plus 1. We want to know if it's injective. All right. So we want to know if it's injective. What we're going to do is we're going to solve it in two parts. We just create this into two functions. Function of A and function of B. So it means that wherever I see x, I impute A, right? So this is going to be 2A plus 1. Then we equate them together. And this is going to be 2B plus 1. We equate them together. So since we're having 2A and we bring the two equations together, 2A equals 2B, and we can cancel out 2, okay? So A is equal to B. So if A is equal to B, if we have an equation that is equal to the other, we say, oh, it is injective. It is injective. So for instance, let's say we're giving A and B the function of 1. So if A is 1 and B is 1, if they are both giving us something like the same value, like, okay, if A is equal to 1, this is going to be 3, right? And if B is equal to 1, this is going to be 3, right? So we're going to have like 3 equals 3. So we can say that is injective. Injective does not really have problem. Remember, injective is the guy that doesn't care if another person is in the codomain. He just knows that it is uniquely paired. That is injective. But to show for surjectivity, all right, if we want to find out for surjectivity, so the function says fx is read as what? 2x plus 1, right? Says 2x plus 1. So we have fx read as 2x plus 1. What we do is that we replace the function as y. Okay, this is for surjectivity now. Okay, to test for surjectivity, we replace it as y, and then we solve for x. After solving for x, make y, put y as a real number, put y as 1 or put y as 2, and solve and see if it's going to give you something that makes sense, like a real number as well. So then we solve for x. So we say y equals 2x, right? Plus 1. Move 1 to this side, it becomes, we're looking for x, so this becomes y minus 1 equals 2x. And then we divide all through by 2, right? So that x can stand on its own. So here now we have x equals y minus 1, right? So x now is equal to, now let's give y a value. If y is a real number like 1, start with 1. 1 is a real number, right? So we start with one real positive number. So x will be equal to 1 over 2, 1 minus 1. And that's going to give us what? This is 1 over 2 times 0, and that is 0. And 0 is a real number. It belongs to the set of real numbers. So that means it is surjective. If you check this one now, 3 also belongs to the set of real numbers. Injective. 0 here belongs to the set of real numbers. Surjective. That's how we test. Don't worry, we're going to try the second one. Then you'll see it. I think that one is even more, more explanatory. The same thing. So, okay, can we go into the second? All right. Now, for the second one, it says that the function fx is equal to, we have x squared plus 2 over x squared plus 1. That's what it says in this other one, the second one, right? X squared plus 2 equals x squared plus 1. Now, let's solve for injective. For injective, we create what? Two functions. So we say, let function A be equal to function B. So let's see if it's injective. If it's not the same, if it's not the same, we cannot have it. Let's go on. So this becomes a squared plus 2. We're going to test now. A squared plus 2 over a squared plus 1, right? That's a function, right? equals the same thing here now, b squared plus 2 over b squared plus 1. That's the same thing, huh? Then we go on. Then say a squared plus 2 over b squared plus 2. So can we observe anything? If we're trying to find a square, or we're trying to find b, if we bring it all together, a square, a and a, they're all having a square, and we say here now we're bringing a square, and here now we're bringing the variable b square all together. Let's say we want to find a. So if we want to find a, we say that a will be, we find the square root, so we'll find square root. This will be plus or minus square root of b square. So this cancels this. A now is equal to plus or minus b, because square root will cancel this. And plus or minus b means two values. So we're having a square equal to b square, and that does not mean a is equal to b. Remember, in injective, in this other one, a directly is equal to b. 3 is equal to 3. Okay, so a directly is equal to b. A on its own is equal to b on its own. In here now, we're having something else. We're having something different. We're having a square, not a, equals to b square. And then if we solve for a, we're having a equals plus or minus b. So that means a is now having two values of b, and b is having two values of a. So if we solve for b, b2 will be equals to what? Plus or minus a. So that means b is having two values of a is also having two values of b. So if we put that accordingly, it is possible to have a, if we put it accordingly, like start putting in values. Let's say we start with 1, or we start with 2, like that. We start putting in values. We see that the function of a, okay, we see that it will get to a point that a directly is not equal to b, because they're having two functions. It's having two values. A is having plus b, and a is also having negative b. B is having plus a, and b is also having negative a. So a is not equal to b. So this one now is not injective at all. It's not injective. Question? Any questions?
So just to confirm, is it subjective because at least it has one output in the core domain?
How do you mean? We've not yet solved for subjectivity.
So if it's not injective,
Yeah.
I was assuming it's subjective.
Oh, no. Sometimes it cannot be injective and also not be subjective. Sometimes it can be injective and not subjective. Sometimes it can be subjective and not injective. We just need to solve it first and see what we get. For subjectivity, we have to make y, we put y as a real value. Just remember what we did here. Remember this. For subjectivity, we put a function as y, and then we solve for x. So the same thing we're going to do here. And then we make y, we give y a real value.
Okay.
So we check. We are going to do the same now for the subjectivity. All right, so let's go. We have the function of x squared plus 2 over x squared plus 1. So what we're going to do is to show subjectivity, y is given belongs to real numbers, and then we say the function of x is equal to y. So that means we have y equal to x squared plus 2 over x squared plus 1. And then we move further. We then solve for x. So x squared plus 2 over x squared plus 1. So we can solve for x, bring out x, we factorize, or we bring out x. If we do this, we're going to have, let me see. So if I cross multiply this, I'm going to have x squared plus 2 equals y parentheses x squared plus 1. So I take -2, I take 2 to this side. 1 second. I'm going to have x squared equals y parentheses x squared plus 1, and then I have -2. So what I'm going to do here, okay, so I also make y here subject of formula. I divide through by, I'm just trying to make x come out. So I divide through here by x squared plus 1. So this cancels this. I'm having x squared over x squared plus 1 equals y minus 2, right?
So why do you bring in the x plus 1 again? The x
I
squared
want
plus
x, yeah, I want x to be on one side. It's just x squared.
isn't that supposed to be square? Like, isn't it supposed to be maybe finding the square roots of both sides?
If we find the square root of both sides, it's going to be affected. We'll have -2 affected as well, as we'll have this one also affected as well. So I just want x to be on one side. You get everything is going to comprise of it, but let x just stay on one side. So x becomes 1. You get, let x become 1, just one equation. So I can just have x equals my plus or minus square root of, that's what I need. Okay, so let's see. Okay, so now we're going to use this. We have the plus or minus here. And so here now we're having x equals, this is x equals, this is plus or minus square root of y minus 2. One second. And then here too, we're having x plus 1. All right. So I'm trying to see if it's going to be injective, if it's going to be surjective. So if I bring this together, I'm having something like this. Let's factor out x. If I factor out x, I'm having just 1 over 1 plus 1. Okay. All right. I think I should just factor out x before. Oh, sorry. Move. All right. Let me factor out x from here because this is, I've gotten my answer, but I'm just trying to explain it. Let me factor out x from here. So if I factor out x, I'm just going to have only x, right? I just want x to stand on its own. So we'll not get this. So if I factor out x, I bring out x here. So I'm going to be left with 1 over x plus 1 here. Right? If I factor out x, or if I bring out x, it's going to be 1 over x plus 1. And then what else? Okay, I put x in this side. I'm having plus or minus. I make x subject formula. I'm having plus or minus square root of y minus 2 over square root of x minus 1. Let's make y equals 2. Let's make y equals 1. So if we make y equals 1, I'm going to have plus or minus square root of 1 minus 2 over x minus 1. Okay, so square root of 1 minus 2 is negative 1 over x minus 1. And negative 1, we cannot find the square root of a negative number. So
Undefined.
actually, this is going to give us a complex number. It's called I in mathematics, and we just represent it as I. Or sometimes you can type it in your calculator, you're going to get math error, or sometimes they put it as I, or they'll tell you syntax error or something like that. But we use I, we call it a complex number. So math has a way of solving for this. So we're having I, which is complex, meaning that we can't find the square root of a negative number. We can't find the square root of a negative number. So if we can't find the square root of a negative number, it means that y, when y is equated to 1, or when y is equal to a real number, it's not giving us any value. It's giving us I. It's giving us a complex number, or it's giving us something that is not making sense. The equation on its own is not making sense. So if the equation is not making sense, or it's not giving us something that is close to a real number, where we're having square root of negative 1, that means it's also not, it's not surjective. It's not surjective. So, and if you want to even make it shorter, instead of doing all these things, from here, where you have x squared plus 2, you put it at the other side, and here you have y plus or minus square root of y minus 2. You can just try and see, okay, let me replace y. So let me put y as a real number. Let's say I start my real number with 1. Can it go? Is it possible? No. What if I start my real number as I start my real number with 0? Let me not even use 1. Let's start with 0. This is going to give me negative 2. If I use 1, it's going to give me negative 1. And we cannot still find the square root of those numbers. So from the test already, we just see that this is not surjective. So
How about if we assume, let's say 17,
okay,
and that will give us
if you
4,
assume 17,
and it gives something like 4. After finding this,
17.
I mean, sorry, 18. I mean,
Okay, so if you're going to be using set of real numbers, or you're going to be using the range or set of real numbers, the range or set of real numbers is going to start, you start your real numbers from your first set, 0, 1. It has to give you, look, if it's giving you something for 18, that means it should work for 0, it should work for 1, it should work for 2. Do you
okay.
get? So if it's going to be a real number, it means if I put in a real number, I'm going to have a good result. That's the meaning. So I don't really need, yeah, you have to start with like 1, you have to start with 0, 1, 2, thereabout, within that range. Because if it's giving you something for 18, that means you should work for 0. If it's giving you something for 12, or maybe for 14 or whatever, it should give you something for 0. It should start with 1. So if you start with a test with 0, 1, 2, it's not working. And maybe you go and put 18 and you say, okay, it's working and it's subjective. No, it's not. It's wrong, because it's not subjective. It didn't work for the first ones, but it's working for the other ones, meaning that it's not working for all real numbers. That means y is not. That means y actually does not now belong to the set of real numbers. It only belongs to some factors. That's what you're saying. Maybe it belongs to 18 or specific numbers. that when we subtract, we're going to have a perfect square. So it's not all real numbers, but instead, y is meant to belong to all real numbers. So
I
if
was
0, 1
thinking,
cannot work,
sorry, I was thinking subjective means that every possible output, like codomain, is going to map to at least one this thing.
in surjective, everything in the domain must be uniquely paired. In surjective, Princess, I'm coming. In surjective, everything in the domain must be uniquely paired. Nothing should be left out. So in what we just solved, you solved for 18, but it didn't work for 1.
Okay.
That is not surjective. So if this k is the set of real numbers, so are we saying that the 5 is not uniquely paired? That's just like saying 0 is not uniquely paired, or 1 is not
Okay.
uniquely paired,
I
but it's
get
working for k, so it is not surjective.
Thank
Do you
you.
understand?
Yes.
Okay. Yes, Princess.
Hi, please. I'm really sorry, but honestly, this one I refuse to enter. And again, when do I know when to solve it like this? And then there is this place you said you factor x or something, then you put x, then in brackets 1/x minus, where is that safe? So I was wondering, okay, yeah, it's here. If x times 1 is not x, but what we had here is x squared.
Oh yeah, this is you're saying this is meant to be x, right? Okay, we found the square root, and then I factorized. So there was a square root
Oh,
gotten here, then I factorized it, I brought out x, then we're left with just 1/x, because this one is beneath it. If we multiply, that is this. So I factorized the x square, then we're left with just 1/x. So, and even if we impute it, or we say we want to replace this as just 1, if we factorize both the numerator and denominator, this would be like 0, right? Undefined, to be 0. And then we'll still be left with this. We're still left with checking if y can be a real number or not. And if it works for, maybe it works for a bigger number and doesn't work for 1, just start with 0 and 1. If you're testing for y, start with 0, start with 1. Check, can this thing even work? If it can't work, that means it's not surjective. Surjective means that it must contain it. It must work. Just like, how we explained together with Chris here for our surjective. It must work. This is subjective as well, okay? But this one is not surjective. So if the beginning numbers are not working, just understand that it means that it's not surjective. It's meant to belong to a set of real numbers. So if it's not working for the beginning numbers, then
okay.
yeah. Okay. All right. All right. Let's deal with this. So let us say we have, yeah. So this is test for injectivity and subjectivity. All right. Just test for injectivity, test for subjectivity. Do you have any further questions before we push further?
Yes, please. When do I know when to solve it like this? Like, or how do I know it? Or is it when I see a question being written this way, then I know it's for test? I don't get it.
Oh yes, they will ask you to test if it determine if this is an injective equation, if this is the function is injective, or if it is surjective. Like you see the question there. Determine if it's injective or surjective. Then you just you solve and know that yes.
Okay, please, can you solve with another equation, please?
Okay, yeah, sure. Let's try another one. Let's try something more. Let's try something interesting. Let me see. Okay, so let's say we have an equation. Let me use our professor's let me use Danjuma's way of giving us an equation. We've been given an equation like this. If the function of R to be a set of real numbers, right? And then we have it defined as x to Euler to the power of x. Okay, let me make this natural. Let's put it as natural log. Okay, so we have natural log to the power of x. That's the meaning of that e. All right, so because sometimes e also means, it also means Euler. That's the power of the e. So let's test this one. Let's see if this one is injective, or let's see if it is surjective. So for injective now, we're going to have two functions, huh? One to A and the other to B. We're going to have two functions, one to A and the other one to B. Now, we'll put it in two ways, right? So we have E to A is logarithm, right? So X now, this is where the X is. So we have E to A equals E to the power of B. And whenever you're dealing with natural logarithm, you need to introduce your logarithm. So we introduce our logarithm. We say the logarithm of a natural number. To solve that, we say the logarithm of a natural number base e to the power of a equals the logarithm of a natural log base e to the power of b. This is injective. We're testing for injective. Injective has to deal with two functions now. And then when you have things like this in logarithm, okay, let me just touch this. Whenever we're looking for a log, okay, when we have the log, okay, when we have the logarithm of a base, the logarithm is in this is logarithm 10 or log 10 base 10. When you see that the logarithm of the base is the same, it means it is 1. But let's leave that one first. When you have a logarithm raised to a power, what you do is that you transfer that little guy to the back of the logarithm. You transfer it behind the logarithm. Okay, I'm just putting this quick one. So log 10 base 10 means 2 log 10 base 10. So this means 2 times. When a logarithm is raised to the same base, it is 1. So this means 2 times 1, which is 2. Okay, so let's say we have log 3. Okay, let's say we have log 3 base 9 to the power of 2. It means that this 2 comes behind. If we express this, this means 2 times log 9 base 3. Do you see this? That's the meaning. We can also still express it as 2 times, okay, log 3 to the power of 2 base 3. And then this same 2 will still come behind again. So any power that we have, okay, it goes behind the logarithm. That's how we express it, right? If I have log, let's say I have log 100. So what this means is log 10 to the power of 2 base 10. I move small guy to this side, it becomes 2 log 10 base 10. So in logarithm, just move that tiny guy, okay? Move the power, the exponent behind it. So, okay, I was just trying to explain that part. So for this injectivity now, this one is going to be what? It's going to be a log. That's going to be a log e base e. And this means a, because e base e is 1. Log e base e is 1. So we just, the logarithm of the same base is 1. So we have a. If this side is a, the same thing is going to happen to b because they are the same. So we're having a equals to b. This one is injective. This one is injective. We don't have problem in this one. is actually injective. Okay, so this one is injective. Then let's check for subjectivity. If we want to find if it is subjective now, let me create space. So to find if it is subjective, we just say that our y, let y belong to real numbers, right? And then we have our fx, meaning that the function of x will be y. So we have e to the power of x equals y. Okay, so that means we then solve. Now, another thing we need to understand in logarithm, to find the logarithm of something like this, or to get the logarithm of things like this, okay, it becomes this. Let's say we have 2 to the power of 3 equal to 5. So to change this into logarithm, or to find the logarithm of this, it becomes, we say 2 will carry 5 and it will be equal to the power. So what this means is just follow the step, this step 1, exponent equal. I'm just explaining logarithm now because it's part of our basic math. So this will become what? So we're going to say log, okay, log 2, all right, 5, so equal to our power, which is 3. This is how you solve things like this in logarithm. Take for another instance, we have 3 to the power of 2 equals, let's say equals 6. So what this is, if we want to convert this to logarithm, is going to be what? Log 6, right, base 3 is equal to the power, which is 2. That's how you solve it. Let's say you have, let's say we have an equation like this, 10 to the power of 2 equals 10, or let's say equals 100. If you want to solve this, you say what? Log, okay, 100 base 10 equals to the power 2. I hope you're getting it. So this is how you break down when you want to change an exponent into logarithm. This is how you break it down. So here now we're having e to the power of x equals y. So if we want to convert this to logarithm, because e is natural log, right? So we introduce logarithm whenever we see this e. So it's going to be what? Log y base e equals x. So if we now start testing, okay, so let us test. Since y is meant to be a set of real numbers, the best thing you do, just start checking for y. What if, can we find the logarithm? The first question is, can we find the logarithm of a negative number? We cannot even find the logarithm of a negative number. So this one is not subjective. From the beginning, you just start with, you can start with -1, start with 0. Just start with -1 first, test it. Okay, test it. Start with -1 and test the equation. Can we find the logarithm of that number? So we can't find the logarithm of a negative number. So it's not subjective. So you might be wondering, why did we use -1 here? Why do we use? The reason is this: for real numbers, it just has to work. It does not have any excuse, no excuse. For real numbers, something has to work. Okay, something must work for real numbers. That's just the meaning. Something must work. Now, if we define real numbers, remember last semester they talked about real numbers and all that. Real numbers are like any values, okay, that can be represented on a continuous number line. So that means all rational numbers, even fractions and repeating decimals, okay, as long as it can be represented on a number line. So inside real numbers, we have natural numbers like 1, 2, 3. Like you start counting from natural numbers, 1, 2, 3. Inside real numbers, we also have whole numbers. Whole numbers are like we have 0, 1, 2, 3, and it goes on like that. Inside real numbers, we have integers. Integers are like, you have negative and you have positive. That's -3, -2, -1, 0, 1, 2, 3, 4, 5. I'm just telling us for those that might be confused why we're using -1. You need to test it from any angle. In rational numbers can be expressed as a fraction. So 3 means 3 over 1. 0.5 is 1 over 2. You understand? 0.25, 1 over 4. All these are what? Rational. They are inside real numbers. They're inside real numbers. Okay. We cannot find the square root of a negative number because it's not even an irrational. That's mass error. That's complex number. But irrational numbers like that cannot be written as a simple fraction, like square root of 2. Those are irrational numbers. Doesn't make sense. All right. It can be found in a real number. So the things that real numbers do not include complex numbers like that one we talked about, the I. Once you see that square root of -1, or they don't include infinity. No, they don't include infinity at all. So that's why. Now, can we find the logarithm of a negative number? Answer is no. This one is not surjective. So if we check it, this one was injective but not surjective. It was injective, correct, but it's not surjective. So if it is injective, it doesn't mean that it will be surjective. Or if it is not injective, doesn't mean at the same time that it will be not surjective. So you need to really you need to solve it to determine what it entails. So yeah, that's it. Then you can ask your question. Yes.
Okay, so is there like a shortcut, because most of this question might come in many numbers, like answer it in number 10, answer it, answer, and so is there like a
The shortcut,
shortcut?
yes, the shortcut for it is immediately you get, if you're testing for subjective, immediately you arrange it, start testing for your y. Put y as -1 from the onset, or put y as 0, put y as 1, put y as something from the onset. Test it. When we're looking for real numbers, can this thing work for, if it cannot work for -1, sorry, excuse me, if it cannot work for -1 but it's working for 1, we cannot accept it. Because one of the real number cancelled out, so it's not subjective.
Okay.
You just test it immediately. If it's not subjective, it's not bijective, because bijective means it has to be both subjective and injective. So if it's not subjective, it's not bijective. The same thing with injective. Just split the equation into 2, solve for A, solve for B, or test it as A and B. Do we have A to equal to B? Like, would A give us direct equality as B? That's how you know that, okay, this one is injective.
Okay. So from the few examples you shared, it feels like the equations with fraction are likely going to be subjective.
Yeah. Equations with fraction.
Yes.
This one was with fraction now, Abi.
Yes.
Well, it's not subjective. Because real number did not work inside of it. It doesn't belong to real number. When we tested square root of -1 or square root of, it gave us complex number I. And when we have complex number like that, it doesn't work.
Okay. Thank you.
You're welcome. So let's now we are understanding injectivity and all that, subjectivity, mapping, domain, range, and all. So I think we're good with that one. So we can now move into like value of a function itself. Okay, we'll get into function and then we solve for function. And yeah, so once we can deal with function and we're good with function, our next thing will be to dive into that differential calculus and all that. So yeah, differential calculus and all. We'll actually go through our questions. The questions from the LMS, I'm going to share it. So we'll go through those questions. Let me see. Yeah, we'll go through the ones that they talked about functions, all right, and then we'll test it. So first of all, let's go into functions. Okay, let's go into functions. Going to functions, we talk about the limiting of a function. All right, so I'll do that. Talk about infinity and negative infinity. So before I move into that, do we have any questions? I hope we're not sleeping. Do you have any questions? I told you guys it's 4-hour class. 4 hours first, then 1 hour break, then we'll go again. So let's stay cheeky. All right. Let's move into the value of a function. Let's deal with this. All right, let's move into the value of a function. So a function takes another value when the function is redefined. So first of all, if you check almost all the questions that we're dealing with, we have to define the function, right? So it's that redefinition that can be real numbers, or we have multiple or formal variables. For instance, let's say we have something like this. Let's say if the function of x is equal to 2x plus 1, and it's telling us to find the function of 3x, telling us to find the function of 3x. So what this means is the question is saying, okay, find 3x, meaning impute 3x into x. So wherever we see x, we impute it as 3x. So to solve this one, we just say the function of 3x is going to be 2 parentheses. Instead of x now, we have 3x, then plus 1. And that is going to give us 6x plus 1. Just like you are substituting in a football match. All right? That's one of the sweet parts of functions. Just as if you're substituting in the football match and all. All right, so if we have another one, let's take another one. Let's say we have if the function of x is equal to, let's say we have 10x minus 3, and it says find the function of 2. Can we solve this? Okay.
That should be 10 times 2. That is 20 minus 3, 17.
Yeah, that is 17. Yes, Princess. You wanted to ask a question?
No, I wanted to say what I got. So I got 17 as well.
Okay, yes. All right, thank you. Thank you, Chris. Thank you, Christian. So that is yes, 10 times 2 minus 3, and that is equal to 17. That is 20 minus 3. It's 20 minus 3, and that is 17. All right, so what if we have the function of 2x minus 3, and this function of 2x minus 3 is equal to 4x squared plus 5x plus 2, huh? And it says find the function of 1. So what do we do for situations like this? When you have a function already having an equation in the function, and it's telling you to find another function, let me give you a hint. You have to equate these functions first so that you can get clarity on what you're solving for. When you get clarity on what you're solving for, you then equate it into this equation. So, or let me do this one. For things like this, we already have the function we have the function of, we have 2x minus 3, right, equals, have that to be equal to 4x squared plus 5x plus 2. And then it tells us that we should find this of 1. Now, this one is not like saying, it's not like the others where we just have the function of x and we can easily just substitute, right? This one is saying function of 2x minus 3. So first of all, we need to clarify what that x is. So we equate it to this other function, which is 1. So we can get clarity. So we move this and then we solve for x. So we have 2x equals 1 plus 3, and that becomes 2x equals 4. Divide both sides by 2, and x equals 2, right? So x is equal to 2. So if x is equal to 2, that is the function, right? X equals 2. Now we have the function. We solve for this. We impute it as the function of x equals, the function of 1 is reading as 2. So instead of putting in 1 there just like that, we have to clarify. We have to first of all equate this one to this one so we can clarify. In our other examples, is just function of x, find this, we can substitute. Function of x, find function of 2, we can substitute. But this one is saying function of 2x minus 3, find function of 1. We don't substitute, we need clarity so we can get what the x is. So when we get that, so you now solve for the function of 1. So that becomes 4 parentheses 2 square, you got your clarity as 2, plus 5 parentheses 2, then plus 2. And that gives us, this will be 16, right? Yeah, 16 plus 10 plus 2, that's equal to 28. So yeah, you can check that. If you have any questions. Yeah, I wanted that by the time we're done with this class, there's nothing on that function from now till in the future of mathematics that you have problem with. When you just see function, you'll be like, okay, I can do this. That's how it's going to be. So, all right, we're good.
Pronounce the future of mathematics ability after exam. I beg you.
You have one for us to solve regarding the one that has a function of a function, then equating to another equation.
Yes, there's Chris. Rafiat, we might still jam mathematics in 200 level. So I think
God forbid.
just learn this one because just in case of anything. All right. So if f, we have the function of x minus 4 is equal to x squared plus 2x plus 3, and it says find the function of 2. So yeah,
Okay,
so let's
try
solve
that.
this. Yeah.
Okay. Okay. X squared plus 6 squared plus 6 3. 6 plus 12 plus 3. Okay. 6 plus I think I got 51.
Okay, got 51. Second. Yes, that is correct. Yeah, that is correct. So, all right, let's solve it together for those that are they're not clear. So what we do is we get clarity first, okay? So we're having a function of x minus 4, and we're telling us to find the function of 2. So let's get the clarity on what exactly are we imputing. So we need to say, this will be, we get the clarity, x minus 4 equals 2, right? Put this here, and that is x equals 2 plus 4, and that is equal to 6. So that means x equals 6. Now, if x is f is equal to 6, we just impute it here. So the function of 2 would be 6 squared plus 2 parentheses 6 plus 3. And this is 36 plus 12 plus 3. And that is 51. That's how you got 51. There, see? Just like that. All right. So, yeah, we understand now that that's how we actually get clarity. That's what we do to get clarity when you're dealing with function. Okay, when you're dealing with function, if we have if we have the function of, okay, x plus 2, right? If the function of x plus 2 is equal to, we have 2x squared plus 7x minus 5, and it says we should find -1. Okay, so I think you already know what to do for this equation. Find clarity of the function, x plus 2 equals -1, solve for x, then impute it into that equation, and you get your answer. I think we're good with that.
But let me quickly write that down, please. Just want to.
Okay. Next thing we'll be touching is the composition of function. But let's finish this, and then we get to the inverse of a function. And I think that's all the basic we need to learn on the function. We treat just joint cases, and after that, we learn the basic.
Okay, done.
The next thing we'll touch is understanding infinity. You know, yeah, understanding infinity, numbers divided by 0, and things like that. Domain and all that. So, yep, let's go. All right. So yeah, we can solve this and get a value when we're good. So let's just get the entirety of a function. Know that we finish function in this class. And do we have any questions so far? Oh, we're good. All right. So what if we have something else? Okay. Do I stop this one? Okay, let me solve it. Or yeah, this one was for you guys, just like to. Well, anyways, whatever you get, your answer should be -8. Close to that. So let's say we have a value like this. Let's say we have a value like this. We have okay. So if we have a function now, so if the function of x, okay, is equal to 2x squared minus 5x then plus 3, And it says we should now find a function of x plus 1. So this one is already the function of x, right? So we just simply substitute it, like impute x plus 1. So we say we'll just move into the function of x plus 1. So this means wherever we see x, we impute x plus 1. Minus 5 parenthesis x plus 1, then plus 3. And then this will be equal to. So let's solve x plus 1. Okay, let me break this down. Like I said, we'll do it step by step, right? So x plus 1 square means x plus 1. Yes, princess?
Please, can you zoom it in? Like I can't see what you wrote there. Okay, thank you.
You're welcome. So if we open the parenthesis, we're going to have x plus 1 times x plus 1. So to open any parenthesis or to open or expand or distribute, what you do is you multiply what you have in the by the second parenthesis, and then the second value by the second parenthesis. The same thing, you repeat it. So this would be x times x, which is x squared, then plus x times 1, 1x. You can just write that as x. Then we go to 1 now. We use that to multiply everything. Plus 1 times x, that is 1x. You can just write that as 1, as x. Then 1 times 1 is 1. Or you can say 1 squared, whatever. It's still 1. Then we have x squared plus 2x plus 1, right? So I just opened that. I had to distribute. So
Yeah,
if we put out
please stop for me. Divide.
hot mic,
Jesus.
yeah. So if we put it out, the function of x plus 1, we're going to have yeah. So we're going to have 2. This will now be 2x squared plus 2x plus 1, then minus 5 parenthesis x plus 1, right? Then plus 3. I think that's the equation. Okay, yeah, that's the equation. So, okay, let's keep solving down here and just draw a straight line. So I'm gonna have 2 parentheses x squared plus yeah, x squared plus 2x plus 1, then minus, if I open this, 5 times x is 5x, then minus 5 times 1 is negative 5. So I have that to be 5x minus 5. Minus 5x, then minus 5, then plus 3. And then opening this becomes 2x squared plus 4x plus 2 minus 5x minus 5 plus 3. And we collect like terms, right? So this is 2x squared plus 4x. All the x belongs to one side. So collect like terms. Then we have plus 2 minus 5 plus 3. So this is 2x squared plus 4x minus 5x is just minus x. And then 2 minus 5 is minus 3 plus 3. I think this is all 0. So this is what we're left with. 2x squared minus x. That's our answer. Okay, so it's just you doing basic math. It's you doing basic math. I know. Sorry. Yeah. There are others. There are others. You're given a function of, yeah, I would just put it out here. Then we can try to, practice it when we're free. Okay, so do we have any questions here?
So let me quickly write down the question, please. For
Okay.
this,
Okay.
Okay, I'm done. Thank you.
All right, so yeah, let's deal with it. 1 second. All right, so let's just take these other ones and we see how we can, put it out. 1 second. All right, so under functions, let's just take these other ones. We can practice it in our own free time, just to get a clear understanding, master these functions properly. And, so let's say we have the function defined as R to the set of real numbers. Then we have this. Let's say the first one, 4x minus 7. If x is greater than 3, x squared minus 3. If negative 2 is less than or equal to x, which is less than or equal to 3, and then 2x plus 3 if x is less than negative 2. So we're solving for that. Says find the function of negative 1. All right. So if you check here now, you see that the function of x is defined for 3 conditions. For the present problem of f as negative 1, you see if it fits into the one of if negative 2 is less than or equal to x or less than or equal to 3. So what you do is we solve it. We say that if the function of x is equal to the question x squared minus 3. So it goes on like that. X squared minus 3. You say you solve your answer and see if it leads you to negative 2 or if it leads you to something like that. So this is just play around it. I'm dropping the question so you can play around it. So it's not for me to do. We're going into composition of function here, just so we can
I want
cover
to
what we
copy
can cover. Oh, okay.
the top part. Okay, 4x 7. If x is greater than 3, x squared minus 3, f minus 2x minus 3. Less than x greater or equals to 3. 2x plus 3 if x is less than negative 2. Okay, sorry, how would the answer be in 3 different answers? Or
Okay, so for something like this, you solve for, so the question says find the function of f as negative 1. So what you're going to do is you look for the one that actually has a negative. The only one that has a negative is the -2 less than or equal to x less than or equal to 3. That's the one with the negative. So that's where it fits. Okay. So it fits into that equation. So you just solve for that one. So in programs like this, you must take care in identifying the case that applies. So the one that applies is the one that has the range of a negative to the range of a positive. So if you're going to solve for that function, it's x squared minus 3. There are other equations like this as well. You'll see an equation like, okay, 1 second. You see an equation like this. Give me 1 second. I just need to set this reminder. All right, so you see an equation like this. Say we have a function of the function the real numbers and is defined by okay, so here now we have 3x plus 2, 3x minus 2, 5x minus 3. We have this to be x is greater than 4, x here is equal to 4, x here is less than 4. Okay. Says find the function of f4 minus function of -3. So here you can see it is defined as 3 conditions. In here you can see it is positive infinity and here is negative infinity. Okay, it's just less than 4, so it keeps going down to negative infinity. While the other one is greater than 4, so it keeps going to positive infinity, just like that. So what you're going to do is you have to find, all right, it says for 4 and for -3. So you look for the one that is for the function of 4. And the one that actually goes for the function of 4, we have to deal with the one that is equal to 4. That is 3x minus 2. Then if you look at the one that has to go with -3, negative 3 fits into x is less than 4. So in questions like this or problems like this, you have to take time to identify the case properly. Then you can know, okay, this one fits into here. This one fits here. And then you can solve. That's when you're now solving for the function. And then you subtract. So we tend to, just to identify. There are things that are going to expand our knowledge. Sorry?
So you have your answer is going to be just one, not that it's going to be in 3 different.
Yes, your answer will just be 1 when you're done.
Can you hear me?
Yes, your answer will just be 1 when you're done. I can hear you.
Yes. Okay.
All right.
Can I write this down?
Yeah, sure. You can write it down.
Right.
Yes, princess.
Please, I don't get this. Is it that it's done like this, or I don't understand?
Okay. Yeah, so what happens is we need to identify the case properly. That's what it is. We need to identify the case properly. So to identify the case, you look at it. where does the function, where does it fit? If you look at the function of 4, you see that it fits into equal to 4, the one that x is equal. And if you look at the one of -3, it fits into the one that x is less than 4. It means that it belongs to that range. The function belongs to that range. So those are the equation we're going to use. So if we're solving for f to the function of 4, we'll say 3x minus 2. We slot in 4 there and find our answer. For the one of -3, we say 5x minus 3. We slot in -3 as x there and we'll find our answer. Then we subtract the equations and we get our answer. So for cases like this, we need to just check where it fits properly. All right, guys, I think you guys have used like 3 hours here. If you need to stretch, because it's not healthy to just sit down, if you need to stretch for 5 minutes, you can just stretch. I will just take a pause. 5 minutes. If you want to go and get water to drink, you get water. If you need to stretch your back, stretch your back, stretch your legs so that your blood can flow. Okay.
Okay, please take it up a bit. Let me copy the question. Okay, it's okay.
Okay. 5 minutes, just 5 minutes. We'll be here 3:10. Please just stretch the bones or do a little exercise, jump and all that.
Can you help me? Okay, it's okay.
Excuse me.
Yes.
Yes. Yeah, there was a question. You said the answer was -8. It's far back.
Okay.
Okay. Not a little can.
Yeah. Let me take it back. This one said this. Yeah, that's it.
Do you get me?
Yeah, you said that's the question.
Yeah, cause I got 34.
So when you got your clarity, what did you get it as?
-3. It was -3.
Okay, 1 second. Okay, so that is 2 parentheses -3 square. Go on.
Yeah. Yeah.
Plus 7 parentheses -3, then -5.
Yeah. That's 18.
-41.
That's 18 minus 21
18
minus 5.
plus 18 plus 21.
No, 18 minus 21
Minus
minus 5.
Please,
Plus
oh,
times minus
what did I
minus.
miss? Sorry, oh.
No, it's not miss anything. It's just 1 minute. He was asking a question.
Okay. I was supposed to solve this thing because I did. I don't know if I got the answer.
1 minute left.
Okay.
So please, what did you get?
I got minus. Oh, sorry. That's -44. Is that what you got?
I got 34.
I
Okay,
got
let,
20.
let's do it together. It's -8 that is the answer.
Wahala.
Let's do it together. The question says, so we substituted this as our -1 is now 3, right? -3. That's 2 parentheses -3 square, right? Then plus 7 parentheses -3, then -5. Are we done stretching our backs? Welcome back. So this will be 2 parentheses 9, right? Plus times minus is minus. So this is -21. Yeah, -5. So we have 18 minus 21 minus 5.
2 times -9.
Please, what are you solving? Oh?
Or the -3 square is 9.
Yeah, -3 square is 9.
Not -9.
No. -3 square is 9. Just like you say, -3 times -3. Minus times minus is plus. That's the same question Princess asked before.
Okay.
Was it Princess or someone? I don't know.
Please, which equation are you solving?
The one we put on the board earlier. This one.
Oh. Okay. I thought we were at this the function of.
Yeah. He was just asking a question when we went to stretch our back.
Okay, because
Don't worry, you're not lost. You're not lost. Don't worry. You are here with us. Yeah, you're here with us. You're here with us. All right, let's move on.
Sorry, oh, please, oh, for this one, I actually got -41. What did you say is the answer?
Answer is -8. Look at the solution and check it out.
Yeah, I think the issue was around the multiplication of the
Negative number, right?
-9. Yes.
I thought it's the two. I thought that is
Did you use calculator for it, Abby?
No, like that X. I thought it's -4.
No, we have to clarify X. This one we have to get clarity. So to get clarity, you say x plus 1 equals -1.
X plus
Then
one.
when you,
What about the two? I
x
thought it's
plus x
x
plus
plus
2,
two equals to -1.
yeah, x plus 2 rather equals -1. This comes here, it becomes x equals -1, -2, and that is -3. You see that? -1
Oh,
minus 2 is
okay.
minus 2.
I made a mistake. I wrote 3 in place of 2.
Chai, that's why. So now you see it. I
Sorry,
hope you are
please,
indoors.
can you zoom out a little bit?
Okay. Is it for this equation or the last one?
Yeah, for this equations.
Okay. Okay, let's go on. So, all right, so I think we're done stretching, so it should be. Thank you. For those that are tired, there are some people that's not talking at all. I think you're already exhausted. Maybe you're not used to stretch classes like this, or you know, it's somehow because we're combining work and we're combining school and all that. So even throughout next week I took leave from work because MIVA wants to kill us. Okay. This is what we have. So we're going into the composition of functions. That's what we're going into, composition of function. That's going to be the next topic, composition of functions. There are more things to do on that value of function, but I think we all get the gist, right? So I'll drop those other questions to our emails as well. All other materials I need will be sent to the email. I think Glen Academy will send that.
Sorry,
So
is it including the recording?
yeah, including the recording, everything. As long as your email is on that form, you'll be sent. Including the recording, what we're doing today, tomorrow. Today's one will be sent once it's released today. And then same thing with the documents, with the questions from the LMS, answers, explanations, all materials I was able to get. Okay, so let's talk about the composition of functions. So if the function of x is equal to x squared, okay, and then we have another function, and we have another function of x is equal to 2x minus 1. All right, equation says find the function of the function of x. Okay, let me write that clearly. It looks confusing. All right, so find the function of x, and then the second one says find, I'm sorry if it's noisy, I think find the function of the other function of x. Do you see how they're actually touching each other? They're actually moving side by side and touching each other and all that. So if I'm to get this is what it means. Don't worry, breathe. The same thing. So when we're done with this class, nobody will be asking questions on that function again. No matter how they bring the function, you're good with it. All right,
Sorry,
so
please zoom out a bit.
okay. Is that okay?
Yeah, that's okay.
All right, so let us solve this one. The first one says find the function, okay, g to the function of x. They don't want to say f to the function of g. All right, so to get this, I'll first of all say, okay, my g, the other function to the function of x would be g as x squared. Then I will equate it as 2x squared minus 1. Let me break it down. What we first of all do is this. We find the function of f. When we find the function of f, we use what we get to find the function of g. So this equation that was broken into 2 steps can be written more like this. I hope we have this done. I want to zoom in so I can elaborate. Are we good?
1 minute.
Okay. I said 5 minutes break to stretch. Some people are not here yet. Oh my God.
Sorry, is that gx raised to power 2?
Yes,
Oh, wow.
x raised to power 2. I'm going to explain that. How we got that. This is composition of function, and we're dealing with inverse next before joint cases, and
Please,
then
can you zoom in a bit?
zoom in or zoom out. Which one?
This is okay.
Okay.
All right.
All right. Just let me know when, like a thumbs up or any reaction, so I can explain. Okay, good. Now let me break this down. What this means, because it might be looking like jargons. Like, how did I just get 2x squared minus 1? Just like that from the equation. So like I said, you first of all find the function, this function, whatever you get, you replace it to g function. So what I'm going to do is this. The question says g, and then we have a function of a function. So I'll find the function of x. The function of x is equal to x squared. So I don't think there's anything to find anymore. We already have it as x squared. So since I found the function of x to be x squared, I just impute it there. I replace it as g. Instead of me saying g to the function of x, I'll say g to the function of x squared now. I put that into g. And we all know that g already have its own function. Gx function is 2x minus 1. So instead of me putting g to the function of x, I'll now put g to the function of x squared. That's the value of what I got before. That's what I'll impute there. So that's what we did here. And then, so it means wherever I see x, I impute x squared. So instead of 2x minus 1, I say 2x squared minus 1. I will explain the other part. You'll see it. You'll grab what I'm saying. Now, the second one says f to the function of g. So f to the function of g, right? So I'll first of all do the one of I would say this one. I'll first of all solve what is inside here before I replace it. So g to the function of x is equal to 2x plus 1. That's my value. So I then replace it into the function of x. Instead of me having fx now, I won't have fx anymore. I'll have 2x plus 1 inside my fx. And, you know, this is equal to x squared. So it means that wherever we see x, we impute that. So I'm just going to say, instead of writing x squared now, I'll just say 2x plus 1 all squared. Is it 2x plus 1? Okay, minus 1. So 2x minus 1 all squared. That's what I would just say. So I have this 2x is minus 1 or plus 1, sorry. So minus 1 all squared. I just impute that into the equation and then I solve. You see how we're doing it? We're replacing it. So first of all, find the function inside this. Whatever value we get, we replace it as the function of the other one. So now this will be equal to, I open the parenthesis, right? So I think we all know how to open a parenthesis. So we have 2x minus 1, 2x minus 1, all squared, right? So this means 2x minus 1, and this is also 2x minus 1. So we can open a parenthesis. So yeah, someone help us open the parenthesis. Let's get our final answer.
Please, if you're talking, I can't hear you.
No, I'm not talking. I'm waiting for you guys.
Okay, you want us to solve this?
Yeah, I want you to open the parenthesis. I want you to expand.
Okay. So I got 2x squared plus 4x minus 1.
Mm-hmm.
Is that correct?
Sorry, what did you say? Say that again.
2x squared minus 4x minus 1. I mean plus 4x minus 1.
Well, when you say 2x squared, you mean, okay, 2x all squared, right?
Yes.
Oh, okay. So that is like we're saying 4x squared. Okay, plus 4x, yeah. Yeah, minus 1. Okay. Yeah. That is correct.
Okay.
That is correct. It's good, 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 good.
Please zoom out.
I got 4x squared minus 4x plus 1.
You got a plus 1?
Yes.
Okay, let me see. Let's open it. Let's open it. I think I'm having another value here. Let's say we have this. So 2x minus 1, 2x. Oh, minus times minus is meant to be plus. So this one is going to be negative, right? Okay. I see that. So 2x times 2x, then 2x times negative 1. We apply the same to this other side. So this becomes 4x squared minus 2x, then plus 1. All right, so that is yes. That is 4x squared minus 4x then plus 1. Okay, thank you, Jesse, for that correction.
Sorry, minus 2x
I
minus
don't
2.
understand. It's -2 -2 -4. I don't get.
Yes, like you owe 2 and you owe 2, so that means you owe 4 together. Minus minus, that means we add. Remember?
Okay, minus plus.
Yeah, so we add. You're owing 2 and you're owing 2, so you owe 4 together. That's it. All right, let's move. Okay, I think we're just explaining this one. So let's what if we have something like this? This is composition of a function now.
Sorry,
Okay.
let me compare something quickly.
Okay.
So the answer to our question now, the A part is 2x squared minus 1. That's the function of x. Right?
Yes.
D to the
2x
function
squared.
of x, 2x squared minus 1. Then
Yes.
function of g to x. Is that how you put the B part? The question.
F
the
F to G. Look at it here. F to G. That's the second one.
Okay, F to G. F to the function of g, or how do you put it?
Yeah, F to the function of G. So we first find G, then we substitute it into F function.
Okay, so that's the answer that we got, the 4x squared minus 4x.
4x plus 1. Yes.
Thank you.
Welcome, boss. All right. So let's deal with this. Let's say we have if f has this function that's 2x plus 1, and you have x to 2 parentheses x minus 2. Okay. Let me make something similar, please. This one might be diving. Let's do something similar so it makes sense, like with what we've done. Let's say if it's the function of x is 2x plus 1 now, and the function of x again is x squared minus 2. And it wants us to find g of f. So sometimes they can put it like this, g of f, or they can put it like this, g to the function of x. Okay, so or they can put it like this, g dot the function of f, and they can express it like that. So just anyhow they put it, just know you know what you're talking about. This is composition. So if we want to solve for g of x, all we're going to do is we'll first of all find this one. The function will then substitute it for g. So the function of f, the function of x that as is defined is equal to 2x plus 1 according to the question that we have. So we then substitute that into g. So it becomes g, that's 2x plus 1. And g 2x plus 1 is having what? X squared minus 2. So wherever we see x, we impute that. So that's going to be 2x plus 1 all squared, then minus 2. And then we can now solve. I think we've already opened this one before. Okay, what we opened was 2x minus 1. So this one now is 2x plus 1. So that means that's going to give us what? That's going to give us, instead of minus now, to be plus. So that's 4 squared plus 4x, then plus 1, right? So instead of minus, to be plus. I hope you get what I did. This one was 2x minus 1. So instead of minus, everything is going to be plus. So then we have minus 2. And we can take it up from there. So we have 4x squared plus 4x, then minus 1 as our final answer. So look at that, check if you've got any questions on that.
Okay, writing it down.
Excuse me. Excuse me.
Yeah.
Yeah, please, can you start again? My connection lost, so I had to go check it, and I lost all you taught since then. I don't know if you can start from this question.
Yeah, sure.
Thank you.
So the equation goes like this. It says that the function of f, fx has a function of 2x plus 1. Then gx has the function of x squared minus 2, right? Then it now says find the function of g of x, of f, meaning g to the function of f. So we first of all find this one here. When we find it, we then replace. So we just do the same thing we did the last time. So f to the function of x is equal to 2x plus 1. Then we substitute, and then we have 2x plus 1 all squared minus 2. And then we solve. So we then had to express this one. This one, we open the parenthesis. We just say, okay, let me open that so we can have clarity. So this is 2x plus 1, right? So all squared means 2x plus 1 all squared. So what we're going to do here is we're going to open it. So this will multiply this, and then this will multiply this. So if I open this, I'm going to have 2x times 2x will be 4x squared, then plus 2x times 1 is 2x, then 1 times 2x is 2x, then 1 times 1 is 1. So that's how I got 4x squared plus 4x plus 1 here, right? 4x squared plus 4x plus 1 here. And then we have minus 2, okay? So we're going to then impute it as that. 1 second. Why is my battery showing battery low and all that? Then we have 4x squared plus 4x minus 1. Then remember the question says minus 2, right? So this is it here, x squared minus 2. So we just put that here as well, and then we solve for it. 1 minus 2 is minus 1. That's how we got the answer.
Thank you.
All right. Welcome, Moses. Okay, so let's go on. So function of a function, that's like composition of a function. We understand that to get the composition of a function, composition of a function, we're likely saying that okay, we first of all find the function and then we link it to the other function. That's what this composition is saying. We'll find one function and then we link it to another function. Okay, so there are other methods and other things, but I think that will be shared in the material. But okay, let's try one more. Then we just try this one. We'll be heading to inverse of a function. I want us to finish all this so we can start treating the domain, negative infinity, positive infinity, get clarity on that. So nothing confuses us at all. It's all broken down. Okay. Don't worry, for those of us that are really exhausted, we'll soon be getting to our break, which is 4 o'clock. So you got this. You got this. All right. So if let's say if the function of x reflects 2x plus 1, and then we have g, the function of x again reflects 2 parentheses x minus 2. Question is saying, what is the value? What is the value of f of g? 1 over 2. So what's the value of f of g to the function of 1 over 2? That's quite you know, technical. So what this is saying is that f to the function of g, not x now, 1 over 2. That's what it's saying. That's what it's saying. So what we're going to do is this. We're going to first of all find the function. We solve for f of g first. So what we're going to do is we solve, before you start imputing 1 over 2, let's first solve for f to the function of gx. That's what we solve for. When we solve this, we first solve this, then we substitute it, then we can get our value, right? So g to the function of x, gx states that what? Gx is what? 2 parentheses x minus 2. Okay, if I should put this out, this is 2x minus 4. Okay, I substitute this into the function of x. So instead of me putting that, I say 2x, I say 2x minus 4, right? And then the function of f is what? 2x plus 1. So wherever I see that, I just impute. So instead of me writing 2x plus 1, I just say 2 parentheses 2x, okay, 2x minus 4, then plus 1. Then what do I have? I have 4x here minus 8, then plus 1. And that is 4x minus 7. Now I have that to be 4x minus 7. I can then solve for this function as 1 over 2. So what I do is I just simply insert 4 parentheses 1 over 2, then minus 7. And to cancel this, so that is 2, right? Minus 7, and that is equal to 5. Right there. So check it out.
Taking it down.
All right. All right. So just let me know when you're done, so I can. So can go on the composition of a function. So that is the gist about composition of a function. I need you to understand it. So do we have any question on it? Because there are others. There are other, you know.
The answer is it minus 5 or 5? I don't get it.
That's minus 5, minus 5. 2 minus 7. Oh, that minus was not there, right? Minus 5. I thought I wrote it there. Yeah, 2 minus 7, that's minus 5. Okay. Tell me So let's touch inverse of a function. That's the
Sorry,
last part. Yes.
sorry. The way we have half g of half to be equals to 4 of half minus 7.
Yes.
I'm trying to understand how we substituted those values. G of
Okay.
half
Yeah, g of half. Go on.
is now equals to 4 of half minus 7 from
Okay.
4x minus 7.
Yeah, we substituted instead of x.
Trying to
Now we're
put it.
putting it as half. You know, the equation says find, this is the question, find f of g of
Okay.
half. So after we had
Okay.
our clarity, we first solved it like as if we're doing normal composition. So after the clarity, what we'll do is we now go straight up and substitute. We then solve it. We substitute that half inside. So first of all, do the clarity first. Solve for
Impression.
gx. Okay. Then after this is gx value. Then when we get that, substitute it into f, function of f to x. Then after that, we then put our half.
Okay.
Mhm.
Thanks.
You're welcome. All right. So let's touch inverse of a function. So yeah, other if I have other questions, I need to, let me see, send to you guys. Yeah, Learn Academy will reach out to you guys in your mail. All right, so yes, let's deal with inverse. So for inverse of a function, let's touch that part. It's, I wanted to be that we're done with the entire basic before we touch base. Next one. So inverse of a function, okay? So if we have a function, let's say we have a function of x, and let's represent that with a variable y, all right? So we say that the inverse of the function is solving the equation in terms of x or in terms of y. Then later we change y to x. For instance, let's say we have something like this. Okay, let me see. Let me just think of one. Okay, let's say we have an equation like this. F to the function of x is equal to 1 over 2 x minus 3, or x over 2 minus 3. And it says find the inverse of x. Find the inverse of x. So we have that equation. It says, okay, this function of f over the set of real numbers is defined by this. And it said we should find the inverse. So if I'm putting this down, all I need to do is, okay, I have the function of x to be equal to 1 over 2 x minus 3, right? Or x over 2 minus 3. I put y as my function. I say, so let y be equal to, okay, let y be equal to 1 over 2 x minus 3. And then I solve for x, or you make x subject formula. So we solve for x. So if we solve for x now, we have y equals x over 2 minus 3. Take this to this side. It becomes y plus 3 equals x over 2. And then we can cross multiply. We then have x to be equal to 2 parentheses y plus 3. Right? That is x. So what you're not going to do here is this value that you got as x, this value you solved as x, your inverse now becomes that value. The inverse of x now will be equal to 2 parentheses. Instead of you writing y, you say that you write what? X plus 3. You change it. That's why I said you change the value. You switch it to x. That's how you solve for inverse. Whatever you get, you switch the value completely. So instead of this x equals 2 parentheses y plus 3, we say the function, the inverse would be 2 parentheses x plus 3, not y plus 3, after we solve for x. Let's try another one. Just check it out first, and then let's try another one so we get clarity on it. So let me know if you're here.
Yes. Taking it down, please. Copy that.
Okay. So are we all good? Do we have any questions? Anybody? Yes.
So this
Princess.
one, can I?
Oh, yeah, sure.
Okay, this 1x over 2 minus 3, can it still be expressed as just x over 2 minus 3?
Yeah, that's what we did here. X over 2 minus 3. We just expressed it
Okay,
as,
okay.
yeah.
So that one is the same. Like,
It's like pure maths, just normal maths. Yes, Princess.
Okay, please don't mind the noise in the background. You said let's work, but there's no why here now. Like, I don't understand this.
Yes, so that's how we do inverse. We say y would represent the function first of all, and then we solve for x. So you can see I dropped down an arrow in the function. I said let y represent that function. Then we put it out there, and then we solve for x. After we solve for x, we exchange y back to x. Okay, that's why I said let me try the second one so that we can see in the second question. Okay, let's do this one. See, it says
Okay.
if,
Sorry, does this mean that if y is what's given, then you can now say let x be?
no, when we're dealing with the function is going to be with that of x. It's always x. These are like, remember, the x-axis. So those functions are going to stay with x. We start putting in y when you get into differential calculus. Yeah, that's when we start dealing with y and the exchange. Okay, so
please scroll down a bit.
that's the whole board.
Like, oh, I'm not seeing the ending part of the answers. It's showing. It's showing from the f inverse. Oh, okay, okay. I see. You didn't expand it further. That's where it
No.
stops.
Yeah. We just had to find, it says find the inverse of the function of x. So we found the inverse.
Okay.
All right, now for this one, it says that if, let's say it says if f is x to the function 2x minus 1, okay, x to the function 2x minus 1, where x is a real number, the question here says that find the value of x, of which it's the inverse. It wants us to find the value of x for which the function of x is also equal to the inverse of x. Quite technical, right? So first of all, what we need to do is let's find the inverse of the function. We already have the function to be what? 2x minus 1. So let's find the inverse of that function. So if we find the inverse of the function, it becomes so let's find the inverse. So the function, normally the function of x is equal to 2x minus 1 according to what is given. So 2x minus 1, right? So we then find the function. So let's find the inverse of that function. So we say let's y. Okay, y now will represent this 2x minus 1. So this is x, please. Y will represent it as 2x minus 1. Then we solve for x. So it becomes, this is y equals 2x minus 1. Take negative 1 to this side, it becomes y plus 1 equals 2x. Divide both sides by 2. So it becomes x now is equal to y plus 1 over 2. So we then say the function, the inverse of x is equal to, instead of you writing y there, you say x plus 1 over 2. That's how you get the inverse. That's how you get your inverse. Okay? Are you with me?
Yes, please. Can we take it down from the beginning?
All right, so the function of x is 2x minus 1. We represent the function as y. We say y equals 2x minus 1. Then we solve for x. While solving for x, we found out that x is equal to y plus 1 over 2. When we want to write the inverse, you say that the inverse of x is equal to, instead of writing that y plus 1, you change y back to x. So y is now x plus 1 over 2. That's how we get inverse. You switch it back. That's inverse. You're bringing it, you're switching it back to x. If you check the first example, that's what we did. Instead of saying equals to 2 parentheses y plus 3, we said 2 parentheses x plus 3 when we wanted to insert the inverse. That's the one here. Okay. So like we put it like that. So what's that? So that's what you do, you switch. But we're not done here. This question says that this is how you get your inverse. I just wanted to get that clarity. That's how you get inverse. This question now says that we should find. It says find the value of which the function of x is equal to the inverse of the function. We already have our inverse of the function to be x plus 1 over 2. So let's find this one. We impute this equation now. So we say fx is what? 2x minus 1. All right. So we have 2x. We have 2x minus 1 equal to the inverse is what? The inverse is x plus 1 over 2. Then we now solve for x. We start solving for x. So we cross multiply. This is 2x. I don't know why it's looking ugly like that. 2x minus 1. Then we cross multiply. So this is x plus 1 equals 2 parentheses 2x minus 1. So this will be x plus 1 equals 4x minus 2. Take x to one side. So collect like terms. Collect like terms. So I'm going to bring 2 to the other side. I'm going to bring 2 to the other side. So this will be 1, negative 2 comes here. 1 plus 2 equals 4x, positive x goes here. So it becomes 4x minus x. So this is 3 equals 3x. Divide both sides by 3 so that x can stand on its own. X equals 1. So that means when we equate the function to the inverse, that's what is here. When we equate it, we have x to be equal to 1. But first of all, we found our inverse. This is the inverse of the equation. Any questions?
So let me be sure that the solution required that we find the value of x where the function is equals to the inverse of same x.
Yes, that's what the question
Okay.
asks of us. So, any further questions? Yes, Princess.
Okay, here that we have x plus 1 equal to 4x minus 2. What if I decide to leave x at the left side and I say
I hear you,
x
sorry.
minus 4x equal to minus 2 minus 1.
You're going to get the same answer. It will be negative 3x equals negative 3. Negative 3 will cancel negative 3. So that is 1.
Okay, let me check it out.
Okay.
You have to tell you. Is in that place that we what kind of work are you applying for? What kind of work are you applying for?
Like data.
Okay.
How much?
What kind of it? You can plug it.
All right. Are we good? Okay. So for now, we're going to be heading to our break. All right. Immediately after the break, we touch one more example, and then we go into learning about domain infinities and the different types of functions, which is just very clear. And then after that, we deal with questions and all. Hey, and then you get to know about me a little bit. So what I do and all those things. So yes, we're going on break now. So we just clock 4 o'clock. Let's get on. 1 second. We have 1 hour for our break. So 1 second. So let me just set.
Can this be on the screen so I can take it, copy it, and place
Can what be on the screen?
the solution? This last answer you just gave us now. Okay, I'm almost done anyways.
Okay, yeah. Let me see.
Sir, will you still be hosting the physics classes today?
No, physics class is tomorrow. Today is maths. Physics is tomorrow. Today is just maths. Don't mind my PR. My PR don't know what they design. Anyways,
Thank you.
today is maths. Today is maths. Okay. So yeah, let me um get this on. Okay, so 1 second, 1 second. So are you done? Are you done with it? Let me share.
Almost.
Okay.
I'm done. Thank you.
All right, all right. So, welcome back. So, if you're still on break, please welcome back. Oh, yeah. I think we're done with the break already. So I hope we went to stretch and all that, please, because it's needed. 1 second. Okay. Okay, so let's continue. Now we understand the inverse of a function. Let me share my screen. So yes, I didn't really go on break. I went to another class. I had a class within that time, so I was taking that class. So that's why I'm still on seats. Maybe it's when we close. That's when I'll take my own break. All right. Okay. Yeah, that's the class I was taking. Let's go back to MIVA practice. Okay. So we have the inverse of a function. We've been able to understand how we switch. Okay, the inverse of a function. So what we're going to do, we know the basics of function now. We're going to move into learning about the notations. And once we learn about the notations, learn about limits and the things like that. Once we learn the notation, understand it properly, know about infinity and negative infinity and positive infinity, how to write out the notations, the explanation to that. We then treat some questions together and we move into differential calculus. So those are the two parts this semester is broken into. So yeah, those are the two parts. So yes, let's now learn about the domain. Thinking about the notation, rather. So let's learn about the notation. So let's say we're trying to find the domain of something. All right, the example says here that says find the domain. Let me first of all get it clear if we're seeing. I hope we're all seeing my screen, please. Good. Let's continue then. Okay, let's continue. 1 second. One second. Just trying to let someone in. Okay. Okay, so let's say we're trying to look for the domain. I think I've let everyone in now. Everyone should have the link. As long as you're registered, it should be there. The domain here says find, the example here says find the domain of f to the function of x equals 1 over x. So the first thing we do for questions like this is where we try and find. This is where we have our notation. Okay, this is where we involve notation. There's some questions that actually involve notation. I need you to understand about those notations so we don't get confused when we say it. So it says find the domain of x, function of x equals 1 over x. So the question is, when does the denominator become 0? The denominator is x. And if we set x to 0, okay, we have the denominator to be x. If we set x, setting x, we set x equal to 0. If we set x equal to 0, the value we get is actually forbidden. The reason why it is forbidden is that it's not defined. So this value is forbidden. We're going to be having something like 1 over 0, and that is not defined. So it's going to be all real numbers, because if we put it at 0, it's going to be all real numbers except 0, because we're going to get 0 when x is equal to 0. Okay, 1 divided by 0, that's not defined. When you have a denominator like that, it means that the equation is not defined. 1 over 0, if you have 2 over 0, this equation is not defined. Things like this is not defined. In mathematics, that's what we call it. We say it is not defined. Or you can just take note that the value is forbidden. So it means that all real numbers are existing except 0. So 0 will not be counted in that part. Okay. Then if we want to now put it in our notation, you'll be seeing something like this. Our final notation, or the interval notation, it will be negative infinity, comma 0, and 0 to positive infinity. So most times when we see things like this, we kind of get, scared or something. Like, what's the meaning of this one? We kind of get scared. What's the meaning of this? Why do we have it set like this? That's how we tend to ask those kind of questions. Why do we have it like this? Why is it like this? Why is it like this? And all that. The infinity means that all negative numbers. That's what the infinity is saying. All negative numbers. Downwards. That's what this guy is saying here. Okay. But not involving 0. And this one is saying not involving 0 and all positive numbers. Let me explain. Yeah, forbidden. That's what we're doing. What we talked about 1 over x, and if we equate x as 0, we say that the value is forbidden. Actually, it is meant to be not defined, but we say that value is not defined. We cannot define it. I want us to understand infinity. I want us to understand this infinity. So when we see it in our questions, we don't get confused. Okay, that's what I need us to understand, the infinity. So what is this infinity we're seeing here? Negative infinity, positive infinity. Let's understand it. Infinity is not a number. It simply means forever. Okay. So if we say positive infinity, we mean 1, 2, 3, 4, 5, 6, ... to your last breath. The thing is that we can never reach the last number when we talk about infinity. So you can keep counting forever. It is that endless idea that it's called infinity. The negative infinity means numbers continue forever in the negative direction. That's the negative number line. And it keeps going. You can never reach the end. Okay. Now, another thing we should understand, because we need to know this notation properly. Another thing we should understand is what we call the parentheses. There are different kinds of parentheses. And Danjuma was kind of explaining that part to us. She made sure she touched it. And I want us to know about the parentheses. You see this parenthesis where you have, let's understand the parentheses. Parentheses in notation. Okay, you see the parentheses where you have just normal brackets like this, our normal brackets, this one. This round bracket means that it is not included. For instance, let's say I have negative infinity, comma 5. What this means is, it means that 5 is not included. It's not. It's not included. So it means you're having something like this. You're having, let's say you have x less than 5. That's the meaning. On a number line, if you want to express x less than 5, you don't include 5. You say 4, 3, 2, 1, 0, -1, -2, and it keeps going like that, down towards the negative infinity, the left part of the number line. But if you say x is less than or equal to 5, now that means something. It means it starts counting from 5. That means 5 is included. Okay, it starts counting from 5 downwards. Suppose we write it like this. Let's say we write it like this: 5 comma infinity. Okay, so this other bracket, this one is called the square bracket. You see this is the square bracket. The square bracket means that 5 is included in our range or in our values. I wanted to just know the difference between these brackets, know how we put down the brackets and all that. It means that 5 is included. So it's like an invitation saying, okay, you may enter, you're part of us. That is what the square bracket means. Then the other one is infinity. Infinity is forever, so we don't really put square brackets with infinity because that is like a forever stuff. So it just keeps going on. Okay, so that,
sorry, so
yeah.
So if you have to represent this on the number line, it's going to start from 5 up.
Yes, it will start from 5 upward. So this means x is greater than or equal to 5. So we put it on a number line. Let's say this is 5. We shade it, and then it goes this way. X is greater than or equal to 5. That's the meaning. We include 5. So that means 5, 6, 7, 8, 9. It keeps going like that forever.
If this was in -5.
If it's -5, we're going to be having two values. It's going to be like this. If it's -5, it's the same thing. So we just start from -5, and then it will keep on going. So -5, this will be -4, -3, -2, -1, 0, 1, 2, and to go down towards the positive infinity. 1, 2, 3, 4, because it is facing this direction, the positive side. So that's what
the way you represent it with the bracket still remains, but
yeah, the way you represent it with the brackets will remain.
Okay.
It's just that one of them includes, the other does not include. Your round brackets do not include. Square brackets means it's present, it includes.
Okay. Can I ask one more question?
Ask, yeah.
Okay, so I'm trying to understand when exactly the square bracket will come to the left or to the right, and when the round bracket will be in the left or right. Like,
so let's say we have x. Let's say we have x is less than or equal to 5. Okay. X is less than or equal to 5. So we're putting it this way: negative infinity to 5. Sorry. Or we can put it this way. 1 second. We include 5 here. Negative infinity to 5. So in this one now, we're going in this direction. All we need to put here is 5, and it keeps on going forever because 5 is included.
okay, so from 5 downwards.
From 5 downwards, exactly.
Okay. So the square bracket comes to the right when the positive value is greater. Yeah, of course, positive will always be greater.
Yeah, the square bracket goes to the here. Now the square bracket is in the left. If you look at it, it means that from 5 upwards. Here the square bracket is in the right. It means from 5, downwards.
Okay.
You get it?
Yes, thank you.
All right. So Okay, so let's keep going. Let's understand it. Let's say we have an equation like this, and we're asked to find the domain. We have a function f to the function of x, right, equals with x, and it says, okay, let us find the domain for this one. Okay, so we need to know, we're trying to put a number inside the bracket. So we're trying to put a number inside the bracket. So for things like this, the number inside the square root must satisfy. Okay, the question goes on, the number inside the square root, the number inside the root must satisfy, it must satisfy x is greater than or equal to 0. So now I just want us to focus on this and see how we represent this in our notation. If x is greater than or equal to 0, it means my brace bracket will start from here, 0, and then I have my positive infinity. So because x is greater than it, from 0 going upwards, I'm going to the right direction, like going right. Okay. See this one. Consider we have this equation now, and if we say x is equal to 9, it works perfectly. If we say x is equal to 25, it works perfectly. All right, in this one, if we say x is equal to 9, it works perfectly. If we say it is equal to 25, it works perfectly. If we say it is equal to -4, for instance, so we cannot find the square root of -4. So negative numbers inside a square root are not allowed in real number calculus. Okay, like I used to say that it gives us an I, which is complex. It means it's a complex number. All right, so let's try something else. Let's see. When we have this square root, try this other one. I want us to put this in a notation. We have the function of x to be equal to the square root of x minus 5. The first thing you do is everything inside the square root must be at least 0, equal to 0. All right, just like what we did here, it must be at least greater than or equal to 0. So everything inside the square root must be at least greater than or equal to 0, meaning that we represent this as x minus 5 greater than or equal to 0. Then if we solve for x, bring this guy here, we have x greater than or equal to what? 5. So if we look at it, our final notation is going to be what? Our final notation will be square bracket 5, comma, positive infinity down, right, keeps going like that. I hope we're getting that notation thing. Okay, so all right, so let's try this. Let's say when we're looking for logarithm, another rule that we should consider, another thing we should consider, logarithm only accepts.
I'm sorry for interrupting. Please, I did not get it, please.
Okay, so which part?
Like the brackets and the like.
Oh, okay, the parentheses.
Yeah.
Okay, so let me just brush up. We said that we want to find the domain. Find the domain of f to the function of x equals 1 over x, and then say set x as 0. That is forbidden because anything that have a denominator of 0 is undefined in mathematics. All right, it is undefined in mathematics. Anything at all that have the a denominator of 0 is actually undefined. So we say that value is forbidden, meaning that it's going to go through negative infinity. Look at this now. I want you to focus here. It's going to go through negative infinity, meaning that it will comprise of all negative numbers, and it will also comprise of all positive numbers, but it will not include 0. It would not include 0. That is what the notation means. Parenthesis. When you have round brackets, all right, it means that 5, look at here now, we're having a round bracket to 5. It means 5 is not included. So if I want to call the values of 5, this also means x is less than 5. If I want to call the values in this notation, I will say 4, 3, 2, 1, 0, -1, -2, -3, 5, and it keeps going left towards the left direction of the number line. That means 5 is not included. Okay. Now, if I should put a square bracket, it means that 5 is included. If I want to read this notation, it means x is greater than or equal to 5. That means I'll say 5, 6, 7, 8, 9, and we keep going right direction of the number line. That means 5 is included. If I say x is less than or equal to 5, because 5 is included, I will the bracket is going to be a square bracket at 5, then with the negative infinity, meaning that from 5 downwards. If 5 is not included, this one would just be a normal round bracket, and then I will have this to just be less than 5. But because it is included, so we have that. So we went on to this part where we have fx to the function of root x. So we put the number inside must satisfy that it is equal to 0. So x has to satisfy it is equal to 0. And if you look at it properly, x greater than or equal to 0, that means 0 is included, and it goes right towards the right direction of the number line. If you look at this part here, we said fx to the function of root x minus 5, which means, so when we have excuse me. So when we have greater than or equal to 0, we put it to the other side. We solve for x, right? When we have a square root, we have to ensure that the number inside must satisfy that it is equal to 0. That's what's inside. So we have x is greater than or equal to 5 because it includes 5. Greater than or equal to means it includes. If it's just x greater than 5, it means it does not include. But when we see this, it means it includes. So because it includes 5, we put in a brace in a square bracket, and we have 5, positive infinity going towards the right side of the number line. I hope you're getting it. Now that is our notation. Okay. One sec. That's the parenthesis. So, Princess, do you have any question?
No, it's clear now.
All right. All right. So let's go on. So let's try logarithm. We have a rule that we need to learn about. We have a rule we need to learn about logarithm and all that. We have that rule. So for logarithm now, oh, there might be others who are not on seat. Also, is there a way to notify them? Oh yeah, John. Okay, let me. All right, give me 1 second. Let me reach out to the management. They should send them an email. 1 second.
An email might not really help because it's only if They can check it now. So an advisor can call. That would be better.
Oh, yes, you said something about the email. Uh, they just sent a general,
Email.
yeah, email
Okay.
again.
I was
So
thinking it would have been more efficient to reach out on WhatsApp or call.
uh,
Maybe an advisor could call them because email now they might not even check till next tomorrow or something.
advisor, this is a private class. Oh.
I was about saying that this is a kind of an opportunity that they shouldn't miss. So they are not the one to be, kind of begging them to join the class.
No, I was
Yeah,
thinking when you said you want the officials to reach out to them, I was thinking maybe it's going to be the school official reaching out to the
no,
students.
it's a private class.
Okay. Oh,
Yeah, it's private
I,
class.
I appreciate.
Mm. But I've sent emails too. I've sent emails to those that put it register on the platform. I see there are more emails. There are more emails. So I just told them that they should ring them again. So they've sent it another. If you check your email now, maybe they even ring you too. They forwarded the same email and told you that the break is over or something.
Oh,
So
thank you.
yeah, so I just sent it to the rest. So yeah, we held something like this last semester too. Okay. So logarithms. All right, John, I think we've reached out. They should be saying it now. Okay. All right. So yes, let's say logarithms only accept positive numbers. That's another thing we should take note of. Logarithms only accept positive numbers. So for instance, let's consider, yeah, logarithms only accept, so let's put it this way. Let's consider we have find the function of x given us as in x, and we're asked to, so for this we're going to start testing numbers. So can we calculate in logarithm, that is like you saying in of 10, in of 1, in of -3. That's the logarithm of 10, logarithm of 1, logarithm of like that. That's the meaning. So can we calculate the logarithm of 10? Yes. Can we calculate the logarithm of 1? Yes. Can we calculate the logarithm of -3? No. It doesn't accept. Okay. It doesn't accept. Uh, 1 second, guys. What is this? New student. All right, so yes, it doesn't accept. Okay, so we cannot find the logarithm of a negative number. Whenever you're dealing with logarithm, always understand that x must be greater than 0. And if I want to express this as a notation, or if I want to put this as a notation, so what's it going to be? This is going to be what? How am I going to express this as a notation?
Zero is greater than infinity.
Okay, so we have 0 comma infinity, right? But x is greater than 0, so that means 0 is not included. That's the meaning. So this is how the bracket is going to be, a round bracket, just like that. So that's it. So we use round brackets because 0 is not allowed. So let's check something else. Let's find the domain of, now we're going to be using our notations and we'll put it together. We'll put in our notations together, okay? So we will combine the conditions together. Let's find the domain. Find the domain of the function of x equals root x over x minus 2. So we remember your square root condition. Like these are like laws. Let's remember that for our square root, what did we say? We say that for square root, when it comes to square root, we say that everything there must be what? Equal to 0. Everything that is inside the square root must at least be equal to 0. Okay, so if we look at it here, we're saying that everything inside the square root is equal to 0. So that's x is greater than or equal to 0. So that's the meaning. Then if we check the other parts, the denominator, when we look at the denominator, we check here now, we have x minus 2, right? So if we check the denominator and we look at the denominator, what is the rule that we talked about for having our denominators? First of all, we said numbers inside the square root cannot be negative. Then we also said, we talked about the square brackets and what the parentheses they mean. Understanding infinity. Then what else? What else? A number, we never divide by 0. So if we never divide by 0, it means that x can never be equal to 2 because we never ever divide by 0. It is forbidden or it is undefined. It is forbidden or it is undefined. So you see that? So we keep going like that. And then it says that, which other one? So for this, our denominator now, for our denominator, we say that x can never or is not equal to 2. Because if it's equal to 2, it's going to give us 0, right? So we combine both the conditions. We combine both of them. So the next now is to put in our combination. So our domain is going to be, so our domain will be what? We have x to be equal to 0, greater than 0. So that means 0 is here. Then we're having x is not equal to 2, right? So 0 is here, not involving 2. And 2, not evolving 2 to infinity. What we're saying here is we have our domain to be square bracket 0, 2 union 2, infinity. So if we look at it properly, I'll be able to explain that x is equal to 0. That's why we put the square bracket. And then it's not involving 2. So x does not involve 2. Okay. And then we have that to also be what's going towards the right direction. So it's going towards infinity. Since it's not involving 2, it is going towards infinity. That's why we have this. So x, this one represents the x, this one represents the direction it is going towards positive infinity or negative infinity, and that is towards positive infinity. If you check here, x is greater than or equal to 0. Oh yes, Chris.
Okay, sorry, I'm trying to know why the union is introduced. Because
Because we're combining both statements.
okay,
You know,
so
we
given
have x is greater than 0, right?
okay, so given an equation, it's now for us to now, based on the rules, equate the x to be to ensure that it's greater than or equals to 0.
Whatever
And
is
then
inside the square root must be
okay,
greater than or equal to 0. Yeah.
okay, so you now check the denominator that it can never be
The same.
0.
Yeah, it can never be 0. So that means x can never be 2. X is not
Okay,
equal to 2.
so that's how we got to form the two ranges where we have this union, this, right?
Exactly.
Okay, thank you.
Yeah. So this is just we understanding the clear basics to get our practice notations before we move into the next part. So yeah, just clearly the basics. Okay, so now what if we have this f to the function of x? Look at this one now. This one is quite similar. It says find the domain. Which one says find the domain of f to the function of x1 over x minus 7. So we know the denominator rule, right? We already know the denominator rule. In denominator rule, whatever we're doing cannot be equal to 0. So that means x can never be equal to 7 because 7 minus 7 will give us 0, right? So if we're going to put in our domain, it's going to be what? Since whatever we're doing can never be equal to 0, x minus 7, right? And then x can never be equal to what? To 7. So what we're going to have will be 2. We're going to have 2 things now. So I'm going to put a union to that as well. So now 7 here, x minus 7 can never be equal to 0. So that means it's going to be negative, going towards negative infinity, and also not involving 7, going towards positive infinity. So we're having both the negative numbers and we have the positive numbers, but none of them would contain 7. None of them is going to have 7. So I can have negative numbers, I can have positive numbers, but they will both not involve 7. That's the meaning of that notation. Positive numbers, negative numbers, downwards, but they cannot have 7. That's the meaning of the notation. So there's more under the notation and understanding notation and all. Yes, Princess.
Please, I can't see what you wrote. Like,
Can you say it?
no, your name is covering it. I'm talking
My
about the answer you got.
my name is covering.
Is it negative infinity that you wrote there?
Yeah, negative infinity, comma 7, and then positive infinity, 7, comma positive infinity.
Then is it parentheses or close
Yes,
bracket?
parentheses, like round brackets. Normal round brackets. Yeah.
Okay. Please, can you explain this like this answer to me.
Okay, yes. We have the negative infinity and we have the positive. The reason is this. In the denominator rule, a denominator cannot be equal to 0 because that's going to be forbidden, right? So our denominator can never be equal to 0. That is forbidden, right? So that means x minus 7 is not equal to 0. X itself must not contain 7. So x can never be equal to 7. X minus 7 itself cannot be equal to 0. That's one part. X on its own cannot be equal to 7 on, that's another part. So that means we can have negative numbers downwards. We can have positive numbers downwards. So that's why in the notation we have negative infinity, comma 7. And then we have 7 again, comma positive infinity, meaning that it will not include 7 in both cases. If we're having negative numbers or if we're having positive numbers, it's not going to include 7. 7 is not included in these numbers for us to have a proper domain. Do you get?
Okay. So, but why is the bracket is closed one?
No, the bracket is round though. It's not closed. Okay, let me put it here. Maybe this is what we had. Negative infinity, comma 7, and then union 7 again, not included, positive infinity. That's exactly what we had. So if it is included, it's going to be like this, square. Or we're going to have a brace. A brace will be somewhere if 7 is included, but 7 is not included, meaning that we can have negative numbers, we can have positive numbers, but we can never have 7 in that equation. But we can have positive numbers, we can have negative numbers, but we can never have 7. You see that? That's the meaning of that notation. Okay, so let's learn this. It says, before we move further, and then we'll learn about limits, L'Hopital rule, and then we keep going like that. So we have a journey. So find the domain of f to the function of x equals the square root of 2x plus 8.
Should you try that?
Yeah, you can try that. Just remember that when you're dealing with square roots, okay, everything inside the square root must be greater than or equal to 0. We use the square root rule.
So for this, I got a
Yes?
I got -4, comma infinity, positive infinity.
So your -4, is this square bracket or is it square bracket or round bracket?
That should be round bracket.
Okay, that means it does not include 4.
Yes.
Okay, and I can see here there's another one. Yeah. Okay, someone said, all right, infinity, -4, and -4 infinity. So that means it's not including 4, and we have negative numbers and we have positive numbers. All right, let's check it out. So remember that everything inside square root rule states that what? The square root rule states that everything inside the parenthesis must be greater than or equal to 0. So we have what's inside the square root rather. So we have 2x plus 8, right? Greater than or equal to 0. And then we solve for x. Put this guy here. We have 2x greater than or equal to -8. Divide both sides by 2. We have x greater than or equal to -4. x greater than or equal to -4, meaning that -4 is contained and then it keeps going right, greater than to the infinity. All right, so check it out. Ask a question.
Okay. Okay, so note that it's going to be going down from -4. It's going to be coming up from -4 to the infinity.
Exactly, to go right direction of the number line.
Okay.
Okay.
So I was
Yeah.
having a little confusion when, though I arrived at x equals to -4, but representing it as whether with a closed parenthesis, which is the square bracket, or the round bracket for the left.
Oh, okay. Yeah. The thing is, because we're having greater than or equal to, that means it's going to include -4. So that's a square bracket.
Okay.
So any further questions? Anyone not clear? Okay, are we good? All right, let's go. Okay, that's good. Let's go. So let's say we have f to the function of x equals square root 5 minus x. And then square root 5 minus x. And then, so this is square root, right? So it means everything inside it. Okay, can we solve this one? Can we attempt this? It's just like the previous example. All right, okay, let me leave you guys to do it. So let's see the answer now.
So let me confirm, the x is also under the square root, right? Not just 5.
Yes, we have 5 minus x, yes.
Okay.
Okay, John, I see your answer.
I got 5 closed brackets, 5 comma positive infinity. Then the round brackets.
All right, let's solve. So I know sometimes we might have little problems with pure maths. When I say pure maths, I mean just, grade level maths. Sometimes it's kind of confusing. We have 5 minus x greater than or equal to 0. We take 5 to the other side, right? So this is negative x greater than or equal to negative 5. We divide both sides by negative 1. Remember the rule of inequalities. Do you remember the rule of inequalities?
Yeah.
When you multiply by a negative number or when you divide both sides by a negative number, the sign flips. That's the rule of inequality. Do you remember that? No, that's just like pure maths. So we divided by negative, right? So that sign will flip. That's just normal inequality. So what we're going to have would be 5 and negative infinity. X is less than or equal to 5 downwards. You're right, you're close to the answer, but it's just that math part. We're expressing that math part.
Okay, I didn't actually like take it to the other side. I rather used 5 and then I got a 5 is greater than or equal to x.
Good.
But
So
but then in the notation I've been waiting, I didn't get it.
okay. So if 5 is greater than or equal to x, that means x is less than or equal to 5, right? If 3 is greater than 1, that means 1 is less than 3. If 3 is greater than 1, that means 1 is less than 3, right? So
Okay.
if you put 5, you put x in this part minus x, you get this, right? And then if 5 is greater than or equal to x, that means x is less than or equal to 5. Then you just express it like this. Yes, Chris.
Okay. So if you multiply or flips by negative, I mean, if you multiply or divide by a negative, the sign flips, right?
Yes, in inequalities. Yes, that's
Okay.
inequality.
So
Rule of inequality.
okay. So what I was doing is just that since 5 minus x equals to, I mean, greater than or equals to 0, when I move the 5 to the other side, it was a minus 5. So minus x becomes minus x greater than or equals to minus 5. So, okay, I get it now. So whether you are dividing or multiplying, it gives you, the sign has to flip.
Exactly.
Okay. Thank you.
You're welcome. Okay, so let's do this for range. Let's do this for range. What if they want you to express range in just notation? Negative infinity, positive infinity, square brackets, round brackets. How do you express it? It's good we just like clear that side, have a good clear picture and understanding about it. Then we can, continue. We can continue and going because we're getting so close to L'Hopital rule and understanding it completely. So you already understand the basics. So there's no more much too much stuff. We'll just go into the types of functions, and we're entering limits, and they're not. We already know the notation because that's what we're learning now. We know the notation, and then we go into L'Hopital's rule. Okay, now let's deal with it this way.
Please, sorry for interruption. This
Yes.
expression, that is the answer. It means that negative infinity, right? Then 5 is like 5 is included or what?
Yes, it means 5 is included. That's why it's in the square bracket.
Okay. Okay, that means from 5 up to negative infinity.
From 5 downwards,
Down.
meaning
Yeah, down.
5. Yes, of course. 5, 4, 3, 2, 1, 0, -1, like that. It keeps going
Okay.
forever. So if we have, you're welcome. So if we have something like this, it says find the range of the function of x, which is x plus 3. It says that x can be any real number because we're looking for the range. So if we look at it, can x be any real number? Yes, that's the answer, because we're looking for the range, right? So we can say if x is equal to 2, it means 2 plus 3, y is 5. If x is equal to 100, it means 100 plus 3, y is 103. If x is equal to -20, let's put it like that. X equals -20. What does it mean? It means y will be equal to -17. So somehow our range is connected. We're going to have a value. So our range, you see when Professor Danjuma put it like, our range would be -infinity, positive infinity. Because we can impute anything. So the value of the function can go negative ways, the function can go positive ways. The function can be negative, it can be positive. It can be negative, it can be positive. Whichever part. So since you can choose any real number for x, you can also obtain any real number for y. So nothing stops the output for this kind of function. So for instance, let's say you have the function of something. We have, let's say, find the range of, they give you something like this. You don't even stress for a question like this. They say find the range of the function of this equal to 5. And they say find the range. This kind of function now, what you're looking at is already telling you that, look, regardless of the input you give to me, I'll always be equal to 5. That's what it's saying. If you put in 1 as x, it will be 5. 10 as x, it will be 5. If you put in -50 as x, it will be 5. It will always be 5. That's what this statement is saying. That's what the statement is saying. And they're just telling you find the range of this statement. That's all. What you now need to do, or the notation for this is the only output possible. This is where you put your curly brackets now. The only output possible is 5. We introduce the curly brackets when we say it is the only output possible. So this means the only output possible. So it means the only output possible is 5. So we can go on and on. If they say find the range of fx equals x squared, you test several values. You test several values. You get your answers. If you test several values, you're getting your answer, and you see you never get a negative answer, it means that that means 0 positive. So whatever we get, we should just know, okay, this is how we're putting our notation. This is how we should put our notation. This is how we should put our notation. So far, let's have a view. And check. If you have any questions, so we can Okay, moving. Yes, Chris.
Okay, so I have a little concern about the fact that the domain being our input and then the range is like the output. Is that right?
Yes, that's
Okay, so
correct.
I'm trying to understand like um how is the domain input in this case? Maybe we take an example and the possible output, which is going to be the range. I'm trying to like balance that.
All right. So in this case here, they're asking us to find the domain. We were given only the range. We're given our output here,
Okay,
and we're asked to find the domain. That means find within what part to what part would this domain contain? Like what can be the possible domain for this? That's when we start solving. Just like when we were dealing with the basics the first time and we had range, we had to do the reverse.
okay, so the equation in the function is actually the function you are working with.
Exactly. Look at this now. We had to do the reverse here. When we were given the domain, we're given the range, and it says find the domain. We use we use the range to get the domain. Look at it here.
Okay,
We use the range to get the domain. We equated everything to the range, and then we started solving for x. So we had to reverse it before we could be able to get our domain. So it's likewise this. This is just an advanced form asking us that find the domain if the function of x is already equal to 1 over x. It's telling us to find the domain. Find the
so for
domain.
that very function,
It has what? Sorry?
like for that very function, we have to find the domain for the
1
given
over
out.
x. Yes.
Okay,
And this one is find the domain of square root x. That's why we're having just our notation. This one is find the domain of square root x minus 5. That's why we're having our notation. It's giving us the notation directly indicating that statement alone.
okay, thank you.
You're welcome. It's just the advanced, this is just the advanced part of what we've done before. So so now let's move into so that is for range, though there are more questions on that range. Things that we need to know, or the things that we need to remember when dealing with range. Things you should know that for domain, you think of things like what can I put into this function? For range, you look at it like what can this function give, or what can it bring out? So when we have x squared for range, you know that it starts from 0. I'm going to give you, okay, let me drop these tips. It's just, okay, which one? When we're dealing with range, when we have x squared, just know that the range starts from 0. It starts at 0. When we have negative x squared, know that the range ends at 0. When we have root x, know that the range again, the range starts at 0. When we have 1 over x, we know that the range, let's say we have a fraction of this, we know that the range is all real numbers. These are just like things to remember, so you know how you put your stuff. All real numbers except 0. What if we have linear functions? Yeah, Danjuma talked about linear functions. So what if we have linear functions? Linear functions always carry mx plus b. I treated linear functions with my enrollees this semester. So that means range is all real numbers. Range is all real numbers. So one thing, let me get one thing straight. So I want us to find this. What is this question? So just take note of this, huh? Because it's still the same thing like we're solving and all that. So I want us to deal with this question. The question says the domain of, so there's a question. It says, what is the domain? Let's see if you can solve this. What is the domain? What is the domain of the function equals 1 over x minus 3? Let's see if you can solve this. So try this one and tell me what the domain is. Tell me what you're going to get as your answer. Remember. So tell me what you get as your answer. So you can have, if it's just going to be an only output or only input like that, tell me. Or if you can express it in your notation like this, tell me, please just tell me something. Let's see. Give me in notation. What is your domain? Yes, Princess.
Please, don't be offended. I got lost. My network disconnected. So I don't even know what happened here now.
Okay, where? Which part? Is it?
The range, you like you just started range when the thing went up, and I came here and I saw that you guys have done like.
Oh, range. Oh, when we're dealing with this, find the range of. Okay, so I wrote down some values of what range can be. We found the range. We said something like this now. Here we have an equation f to the function of x is equal to 5, and the question says we should find the range. For questions like this, okay, to get a question, we already know that it is equated to 5. There's nothing else we can do for that thing. If you're dealing with range, you already know that it is equated to 5. So it means that the only output, that's when we use our curly brackets. It was the curly brackets I was trying to point out. That's when we use our curly brackets. It means that the only thing that we're going to get, all right, will be 5, no matter the input. Whatever input you put, your answers will always only be 5. The equation has blocked out already. Okay, it's different from when you're saying find the function of x to x squared. So when you have find the function of x to x squared, you already have, it means that your range is going to be starting from 0 to infinity. So I just gave us some shortcuts here that we can use to remember about the range. So if it's from x to if it's find the function of, let's say find the range, we have fx and is equal to x squared. What we're going to have here will be 0 to infinity. 0 to infinity. That's what it's going to mean. That's exactly what it's going to mean. So if it is x squared, let's say it is x squared plus 4. Okay. So what we're going to do is, since x squared is already going to start from 0, or what it means that it starts from 0, we're looking to find the range, right? So we start with 0. So we just calculate. We calculate it. So we say, we already know that x squared starts at 0. So adding 4, okay, we take 4 to the other side, or adding 4 goes to the other side. So it means that if we're going to have x squared plus 4, it means it is 0 plus 4. So if this starts from 0, this equation is just going to give us 0 plus 4, and that is equal to 4. So if we're having something like this and you're already seeing something here, it means it's going to start from 4 down to infinity. That's the shortcut. Okay, it's going to start, that's the range. It's going to start from 4 down to infinity. So if it's a negative, this is a shortcut for negative, it means that it ends at 0. It's going to be negative infinity, and then we'll have negative infinity down to 0, ends at 0, when it is negative x squared. Ask to find negative x squared. I just drop it down because we've treated some of it. So I expected us to just get the shortcuts and apply. But this is the question now. And what is the domain of this function? This is the question. We've done domain, right? So let's solve this one. Is this one I want us to solve? This one here.
Okay, please leave it like this. So let me copy this out. Thank you.
I said
Okay.
negative infinity, comma 3, union positive 3, comma negative, positive infinity.
Say that again. Say that again.
The round bracket, negative infinity, comma 3, then union 3, comma positive infinity.
That is correct, Chris. That is absolutely correct. Because you know from our rule, denominator cannot be equal to 0.
0, yeah.
And x cannot be equal to 3. So we're going to have negative numbers and positive numbers, but it is not going to include 3. This is one of the questions from our test, LMS. So it means you already have a clear understanding about it. In fact, if you check it properly, we've done like 2 or 3 questions from LMS, but I didn't make mention. So that, I mean, from our test, weekly, mid-semester test, end semester test, like that. So it means you already have a clear understanding. Yes, that's Princess.
Okay, please. You said that 1/x means range is what? All real numbers. What?
Okay, range is all real numbers except 0.
Okay.
Yeah.
Then the linear. Okay.
Linear function. Yeah. Range is all real numbers.
Right.
So that's actually very good. You found that domain. It means that there's a good understanding of that part. So another thing we are going to look at now. Okay, before I move on, do we have any questions? Any questions at all? Any?
Please, can you show the workings of this?
Is it this other question?
Yes, the 1/x.
Function of x. Okay. So we have fx equals 1/x minus 3, right? Our denominator rule, we know that x minus 3 cannot be equal to 0, right? And x cannot be equal to 3. Right? from the denominator rule, you just know that the denominator cannot be equal to 0 because that's going to be forbidden. And then we know that our x cannot be equal to 3 because 3 minus 3 is going to give us 0, right? So that means we can have negative numbers, but it must not include 3. We can have positive numbers, but must not include 3. That's it. When you just look at it, you just put it. Insert, you put it there. C'est fini. Question? Yes, Princess.
Okay, please. How do we know when to use a union?
Oh, okay. So when we're going to be having both negative and we're going to have positive, if you know that, okay, it means that we're excluding only one number. So that means all real numbers, both negative and positive, are involved except from this, except from 3. So that means we can put it that we cannot just say negative infinity, comma, positive infinity. We can't put it like this. This is wrong because 3, that means we're going to involve 3. So we need to put that 3 is not involved. That's why we're putting a union. So this means all negative number correct, positive numbers correct, but not 3. 3 is not involved. This guy is out of it. That's why we use a round bracket. Okay. All right.
Okay, sorry. That means if the value is minus, we are not going to do this union, right? Like if like let's say we have -3, then and then this negative infinity, we are not going to have union, right?
If we have what as -3, we can impute -3 and it will be correct, but we cannot have 3. So -3 is a value. It belongs to the negative infinity, and that is correct, but we can never have 3. So 3 cannot be involved. That's the question. So far we've learned about the square root rule. We've learned about we've learned about the square root rule. We've learned about the infinity, positive and negative. So the next thing now we're going to be looking at So the next thing that we're going to look at is going to be we'll look into L'Hopital and then we get to limits. I'm sure now we're grabbing the understanding of the entire function thing. So yeah, so it's good. This is what we call solid foundation. Okay, so let's touch limits. Let's touch limits. But before we go into limits, I want to know if we fully understand or we have questions. We have any questions at all? Please let me know before we go into that, because we're going to be Are we okay? All right. So let's kick on. We're going to be touching limits. So let me share this. So we'll be touching limits. Limits at infinity. We're going to be dealing with limits, introduction to limits, and all. So yes, then after we head on to limits, we will drive straight into differentiation. But at this point, and we'll talk about derivatives of specific functions. You know, after limits, we'll discuss about the types of functions. Then we get into calculus. Calculus is actually a very good part, but I just need to show you guys. So yes, this is actually the free sessions. Mostly this is what I do. Okay, so I have a STEM club, and we use the STEM club to try to train students. This is just a brief about me. Train students about tech, engineering, and mathematics. And recently, we did um, we did a portable solar power station for the school. That's what we did. That's what we presented. I put that on social media, but it's not yet here. I don't know why the PR didn't put it. So just to inspire students, especially we're bringing this tech knowledge, engineering knowledge, science knowledge on agriculture, fertility, soil fertility to young children. Okay, we're trying to bridge that gap. It's best to start learning it from scratch, understanding the concept. We have young guys, young students at JSS1, JS2 already collaborating, GitHub, creating websites like beautiful, fantastic websites. Your portfolio sites will help you build it, that kind of thing. So yeah, so yes, it's sponsored by Lead Services and Academy, and that is also in collaboration with the Innovation Center Africa and Educational Access Development Initiative, where we're building, building the future. That's it. So just a little brief because I have to do this, part of our sponsorship, proudly sponsored by Leonard Academy. So now for this, we have the STEM, right? So the STEM is the science, tech, engineering, and mathematics. That's the STEM club that I run. And then what it deals with, agriculture, which is talks about technology, power. Okay, yeah, thank you. Agriculture, technology, and power generation. That's what we're built our agenda. We also have strategic placement to enhance education of tech programs. We create these tech programs, distribute skills to boost productivity for the country, engage in power productivity engineering, and also ensure the education is used for national development, meaning our students or members will give back. So that is me. That is Gideon Wakama. I'm the lead and chief operating officer of the STEM Club. Okay. And yeah, I've got 9 years experience of teaching. I deal with education actually. This is my 9th year in the educational space. You can simply just search Gideon Wakama on Google and it will tell you about me. So I specialize in guiding secondary school students, also university students in maths, physics, chemistry, and also I foster critical thinking and innovation. Okay, so I'm the founder of Educational Asset Development Initiative, Leonard Academy, Rebound Foundation. I'm also the leader of STEM Club Nigeria in collaboration with Innovation Center Africa. And I develop impactful programs, competitions, and projects that empower youth learners, blending academics and real-world skills, technology, and creativity. We have our lead engineer, Michael Ihekwereme. He's an experienced mechanical and electrical engineer for over 6 years in the field. And for the past 4 years, he has focused on renewable energy. So things that deals with solar installation, biogas, and the likes. And supporting installation process across the nation. He's also passionate about educating the next generation, that is with me, and empowering businesses and individuals with sustainable, reliable energy. We have our secretary and virtual administrator, which is Victoria Ashefon. She's a 3 years experience in virtual admin. So she handles most of the PR and tells the team, do the PR and all that, and yeah, organize, manage communications, follow up, and coordination professionally. Then we have Gift Olushola. She's a member assessment review officer and media coordinator. So the person that is in charge of getting all the documents done, sending it to your email, she's the one in charge of that. And she's also in charge of our media and coordinates things like that. So yeah. Assessment reviewer with 3 years of experience in coordinating assessments and reporting. She specializes in tracking member performance through structured examinations and data analysis. So if you are in my class, because I have some of us that enrolled in the last marathon class and they like subscribed to our platform and they're in the class. So they do get updates. So the team actually put in updates like this and so on. So yeah, this is when we started. I started the STEM club. I think that was 2019 or 2021 too. So we've got multiple awards, both in mathematics, in debates, and I've awarded multiple scholarships, both in schools, across different regions of the state. Yes, we also venture into sports. I'm a lover of football, so I have a football club with over 40 players, and yeah, I'm thinking of doing, the business part of it, ensuring that these guys reach the apex of their career and they also help out Nigeria, saying if I can sacrifice for you, you can sacrifice for others. And that has been the journey so far. Yeah, we've gotten medals, we've gone places, we've won things and all that in brands. My own is to take them to Europe, sure. They should come and develop Nigeria. And so this is STEM Club. This is when we started with the engineering project. We were making a power bank, teaching children about batteries and how they can manipulate batteries and all. Then as of last year, we delved into solar, started connecting solar cells to batteries and seeing how we can make use of that, and then we went to present in Yaba this year. I think that was March or February this year, and they got recognition in Yaba. And that's the STEM Club in collaboration with the Innovation Center. So what else do you need to know about me? Tech access. These are the things that we need to do. We want to give access to tech to over 5,000 teenagers and build a productive force in the market. So, our social impact, we want to create and promote communities and competitions that can bring a combined front in agriculture, tech, and engineering. Things that we need as a nation. That's my own goal, to teach and to educate people in the things that we need in a country to bridge that gap, not just teaching them X and Y, but how they can apply this X and Y so that, they can help in national development. So we have a strategy to spread awareness, hosting teenage hackathons, going into platforms, Code Academy, Data Camp, training multiple students, and they in turn, we transform this and train other people as well. So target is the youths. Yes, if the youths can do anything, so if they really want to build, they can build, and this is proof. So the same iota of if I can sacrifice for you, you can sacrifice for others. So we have a fundraiser target, and the fundraiser target is actually $3,000. But well, by God's grace. So that is me. You can reach out to me on my MIVA email, but this is my main email, gideon.wak@gmail.com. Or you can reach out to me. This is my number, 090-722-51917. And then if it's something you would like to be part of and you would like to make any donations, you can kindly reach out to me for further details. I will show you about that. So thank you. So here we go back to this and STEM Club and Learning Academy. So yes, that is just me in a brief. I had to just put that out because it is mandatory to do that. Okay, so yeah, we can continue now with limits. Do we have any questions?
Yeah, so that's a great one. I don't know if you can hear me.
Yes, I can hear you, Chris.
So I really love the initiative, and I have a little concern about how you intend to improve agriculture using technology. So
Oh yeah. I'm into the education part. So what I do is my own mission is train the minds. As of this semester, this semester we treated using our chemical laboratory to make fertilizer. So in the laboratory, if you check this picture, you see the girl there. What she was doing there is titration, and she was titrating chemicals that she's going to use for making soil fertilizer to improve soil fertility and all that. And then, planting on the backyard, planting on their roof, but they need something that's going to enhance it. So using the knowledge of science, which is chemistry and all. So this is where I come in. This is where I push this kind of educations, practical educations that we need. If I'm going to be teaching tech, like we are already in front end development for my team. So what we do is we give them practical steps. They've done the HTML, CSS, they've done Java, they've done React, and these are children, by the way. And so they're pushing forward, and they've built like multiple things. They've done multiple. I can just give them a project and tell them, all right, I need you guys to build this. They'll just tell me, okay, sir. So like in 1 week, 2 weeks, we're done. And I don't want AI. I want you to build from start to finish. Then later, I will check the codes and all that. So that's what that's what we do. I know we try to bridge this gap, not only just knowledge and practical knowledge, not only just X and Y, So that's my initiative. It's just that Nigeria, it could be very difficult to find support in a country like mine. So anyways, yeah, you're saying?
That is really great. I think I love that.
Thank you. It's yeah, that's my vision. So I don't have choice. I will keep on moving with it. Okay, then let's continue with limits. Okay, so we go ahead and we continue our limits. All right, so please confirm you can see my screen. Okay, so let's go. Limits. All right, so let's deal with limits. Now, whenever we're dealing with limits, we need to understand that at some point, our X is going to get to a range, is going to reach a part. Now we understand all those functions and how to implement the functions and all that. So it shouldn't really give us any problem. Now, dealing with limits, 1 second. Yeah, so now dealing with limits, we need to know what is limits. What is a limit, evaluating limits, continuity and discontinuity of limits, or how it continues and how it doesn't continue. So these are the things that Danjuma put in place. Okay, so yeah, I think that's her name, Danjuma. So and then let me see. Oh, the class is ending 9 o'clock. So I don't know if your backup power should be strong, because we're ending 9. It's the marathon. It's what we do. It's what we do. But for those, there are some of us that will still like embark and continue, because Monday, Tuesday, Wednesday, Thursday, I'll be setting aside like for 4 hours. But that is my private class. So we just brushing more. I already have them in the Google My Classroom. So they know, most of them are in the private class. You're not here because I'll still send a video and then I'll go and explain it again. So don't mind them. So yes, break intervals. No. Like Monday we put in like 4 hours, like that. We continue Tuesday, Wednesday, Thursday, Friday, Saturday, like that. We keep going. But that is not this class. That is like private class. Okay, so let's introduce. Let's go straight. Oh, for today we stop at 9. We stop 9 o'clock. Okay.
Okay, so from now till 9, no movement.
No movement. It's 4 hours, 1 break, 1 hour break, and the next 4 hours. It's a stretch.
Oh, wow. God, I beg.
Oh, okay. Let's say 7 o'clock. I'll give us 10 minutes so we can stretch ourselves. Okay, 7 o'clock. I'll give us 10 minutes. All right. So, all right. So let's deal with this limit. Let's kill it. So if I have the limit of a function, it means that my x is approaching something. Sometimes you see the notation like this. It means that on the x-axis, x is actually approaching 1. Sometimes they tell you that x is approaching infinity, which means it keeps on going on forever. So when there's a short way of understanding when you see limits, you solve the equation. The second thing is when you get to the final bus stop, you replace or you substitute the function of x or what it represents. So there are questions. This is actually where they brought out most questions. But let's start with the limit. I just want to give us the introduction about what it means. Then we'll go to limit notation and evaluating limits. So let me give us that definition. So now let's talk about limits. So what is a limit? Let's define it, what it means, how we can bring it out. So remember I said that the limit is actually telling us the close mark or the benchmark of where the x-axis is getting to, where it can be driven to. Okay, do you remember that? So if we define it, all right, if you understand limits, then differentiation and integration becomes much more easier. Okay, so getting closer or closer to something, that's what limit is. It's like a benchmark or what we're doing. So getting closer or closer to something. So sometimes we're getting closer to 1. We're getting closer to infinity. So what we do in equations is we just substitute it. All right. So getting closer or closer to something. Okay. So let's say we have the value of a function that is getting closer to an input. Okay. Let us consider this. Consider the notation. Let's consider the notation. We have a limit. We have x approaching 3 to x plus 1. Okay, so when you see something like this, it's not scary. So we're going to break it down into little pieces. First one, it is read as the limit. Okay, the second thing is the variable we are changing. It is called the independent variable. So we're changing x to approach 3. Okay, so it approaches is not equal. It approaches, it moves closer to 3. So the number x is what? Approaching 3. So it does not necessarily mean that x is equal to 3. And then we have a function of 2x plus 1. So this is the rule. As we move closer or as we approach, it means that x changes to 2. That's the meaning. So if we're going to be reading the expression, it is read as the limit of 2x plus 1 as x approaches 2. Okay, that's what it means. So let's find that limit. So if we're going to find this, we're just going to, as it approaches, we replace. Simple. When it comes to the exam or anything, don't even waste time. Replace. So we just say to solve this, we replace it as 2 parentheses 3 plus 1, and that is 6 plus 1, and that is 7. Just replace. Okay. Replace your equation, and you get your answer. Let's try another one. Let's say we have the limit of 3x plus 4 as x approaches 2. So as x approaches 2. So what we're going to do to solve that, same thing, guys. Replace. Let's go. We'll replace that. That is 3 parentheses 2 plus 4, and that is 6 plus 4, and that's equal to 10. Don't even waste time on it. Replace it. The other things are big grammar, I understand, but we get the gist, right? So let's keep going forward. So let's say we have the limit, and we're going to grab limits and understand limits. So we have the limit 2x minus 7 as x approaches 5. All right, what's the answer, guys? Let's replace.
Three.
Correct. X equals, that means our answer is 3. So this is equal to 3. So not X equals, it's just 3. All right, guys, let's keep going. Let's keep going. Let's enjoy limits, because I know limits is something, well, we're going to enjoy. Let's say we have the limit of x squared plus 5. Don't worry about that square. Don't worry. It's the same thing as x approaches -1. Let's go. Let's go. Do we have an answer?
4.
4. Please remember, I hope you didn't use calculator. This is -1 squared plus 5. -1 times -1 is 1 plus 5. So remember, -1 times that's -1 squared. Minus times minus is positive. 1 times 1 is 1. That's 1. Calculator can sometimes trick us. Like, we've seen that a lot. When it comes to basic math, yeah, yes, Chris, it is 6. So when it comes to basic math, we should the ones that we can do, the mentals we can do, let's do it ourselves. Because sometimes the calculator computation, if you don't impute the computation well, it will be giving you -1. So I'm sure you got -1. That's why I said 4. But the answer is 6. Okay. All right, guys, let's go. Let's go. Let's find, we have the limit. Let's keep going. We have limits x squared minus 3x as x approaches, okay, as x approaches 4. Let's go. Replace and find the answer.
That's 4. Is that correct?
2.
All right, are you saying something? Did you say 2 or did you say 4?
4. I said 4.
Okay, all right.
Yeah,
So,
it's 4. 16 minus 2 is 4. Yeah.
all right, so we have 4 as the answer. So that is 4 square minus 3 parenthesis 4. That's 3x, right? So that's 16 minus 12, and that is 4. All right, guys, let's keep going. This is limits. Limits shouldn't, let's have this one. The limit of 5x plus 9 as x approaches 0. Let's go.
That's
9.
Correct. It is 9. Okay. So this is 5 parenthesis 0 plus 9, and that is 9. 0 plus 9 is 9. All right, let's keep going. So when we talk about approach, what it really means, it means that it is getting closer and closer to the answer. As x gets closer, that's the meaning. All right, as x gets closer. Let's say we have the limit of 2x plus 1. Then as x approaches 3, what's going to be the answer? To be equal to what?
7.
Sharp, sharp, sharp. You guys already. I know that limits will be beans for everybody, Jerry. So Yeah, that's limit, Shark. We're done with limits. We're done with the introduction to limits. Yes, Princess.
Is it possible to have something like fraction? Like let's say limit 2 over something something plus whatever. Then why x is approaching something like that?
Yes, it is possible. You just do
Can
your
you
normal mentals.
can you please use that one, please?
You should do the limits of a fraction. Okay. Let's say we have a limit. We have limits um x over 2 plus 5 as x approaches. Do you want x to approach a fraction, or do you want it to approach a real a natural number? Which one?
A fraction. Then
You want
this
you want
bracket,
x to approach a fraction.
yes. Then this one can it also be squared? Is it possible?
Oh,
Like
wow.
x brackets x over 2 plus 5 squared. Like close black bracket squared.
Yes, it's possible. So what we're going to do is we're going to first of all open the parenthesis. We expand. All right. So we open the parenthesis. Don't worry. It's the same thing. Nothing much here. It's the same thing. The same steps. The same steps. No matter how they twist it, limit is limits. Nothing is going away. So what we're going to have here is simple. We have x over 2 plus 5, and then x over 2 plus 5. We open that parenthesis. This times this, this times this, this times this, this times this. So we expand. So what we're going to have here will be what? X squared over 4 plus 5x over 2 plus 5x over 2, then plus 25, right? And we keep going. So we have x over 4, x squared over 4, then plus 5x over 2, that's over 2, that's 10x over 2, which is going to be 5 over 2x plus 25. So if we express this, this is x squared over 4 plus 5 over 2x plus 25. And then remember the limit. The limit says we have a limit as x approaches, what is it? 3 over 2, right? That's the fraction. Now, wow, Princess. So this means that we just replace, Princess don't mean person this evening. Replace, so this will be 3 over 2 all squared over 4. See equation which you carry come outside. Plus 5 over 2, parenthesis 3 over 2, then plus 25. Then we have this to be, this is 9 over 4 over 4 plus 15 over 4, then plus 25. And 9 over 4 divided by 4 is the same as 9 over 16, right? 9 over 16 plus 15 over 4, then plus 25. And then we can calculate this with our calculator. Princess, calculate this and give us our answer. Princess, hello.
Did you cross multiply all?
No, I didn't cross multiply you at all. I expanded the bracket first. We have x
I
over
mean,
2 plus.
I mean 9 over 4 divided by 4 becoming 9 over 16.
Oh. Okay, look at it here. We have 9 over 4 divided by 4. So when you're dividing a fraction, right? The left hand side stays inbound. Then this side it reciprocates, right? So we
Okay.
now have 1 over 4. So that's the meaning. That's why 9 over 4 is 9 over 16. Do we have an answer yet?
I don't know. I got I got 10.6. Like I approximated. It should have been 10.5 6.
Okay. Okay. Let me. We just need to use a calculator for it. All right. Shall we know the gist now? My princess give us this assignment too. We shall know the gist.
Yes, yes.
All right. So my own answer is, let me see, 9/16 plus 15/4 plus 25. All right. So I'm getting. All right. So yeah. So we're gonna have 469/16. And that can also be expressed as 29.3125. So yeah, our LCM is 16. So to put it like that, we have 9 plus 30 plus 16 times 25, and add that together, we have 469/16. So yeah, so that's it. All right. So does that answer your question, Princess?
Yes, thank you.
Yes, boss.
What
Okay.
is sure? In case there's any complex stuff that will come up, like magic.
Yes, so I don't trust.
All right. So let's move on. So now in this part, we're going to be learning our limit notation. Okay, we'll learn the limit notation. We'll learn the left hand limit. We'll learn the right hand limit when we're going to apply our brackets. When we're going to apply our square brackets. When we're going to apply our round brackets. Um, when we're going to impute. Okay, the meaning of what the notation is. Sometimes we have a positive, sometimes we have a negative. So these are the things that we're going to learn, because we're going to be learning things like that. Yeah. So there are times where when they tell you that find the limit as it approaches negative, 3 negative, find the limit as it approaches 3 positive. These are things that we need to know. Okay, things that we need to know. So let's look at it like this. All right, so this is next part. We have, this is called our, what do you call it again? Yeah, limit notation. So we'll be learning here, limit. Okay, I think I should make that limit. Yeah, don't worry, I did not forget the 10 minutes. Limit notation. Okay, so that's what we're going to be learning, limit notation. So we've learned about limits from the last part. We've learned about how a function, or where a function is heading to. And so we're going to be talking about which direction do we approach from. So sometimes it's like that. So let's say, imagine your school gate. You can reach your school gate from home, or you can reach your school gate from the background. Both paths leads to the same gate. All right. One is from the playground. One is from your home. So you arrived at the same gate, but different directions. That's what limit is doing. So there are 2 ways that we're going to approach this number. There are 2 ways that we're going to approach a limit. We have the positive and we have the negative. So we have what we call the left-hand limit. The left-hand limit asks that what happens when we approach numbers smaller than the given number. So we have the left-hand limit. We have the left-hand limit. So remember your home, right? You're going to the gate, so you can approach the gate from your home. You can approach the gate from the playground. That's what it's saying. So we have the left hand unit limit. This one, the notation of this, the notation is where we have our limit as x approaches a minus to the function of x. This left hand limit. All right, the limit of fx as x approaches a from the left. As x approaches a from the left. That is what we mean by the minus. So what does the minus sign mean? The little minus does not mean subtraction. It simply means approach from the left. That's what it means. All right, then we have what we call the right hand limit. We have the right hand limit. We have the right hand limit. So for the right hand limit, we can approach from the right. Okay, so in this situation, the notation becomes what? The notation becomes the limit of fx as x approaches a from the right. So you see that plus sign. That's what the plus sign means, approaches from the right. So we have something that approaches from the left, and we have another thing that approaches from the right. Okay. So, for instance, things that approach from the left, we can say things that approach from left to right. We can say it as, okay, let's say left can approach as 4.9. We can say 4.99. We can say 4.999. It's still approaching from the left. For the right, we can say 5 point. Yes, please. What's your question?
The positive limit, you know, you said that the 4.99 is negative.
4.99 is not necessarily, like I said, it's not necessarily negative. It means it is approaching from the left.
Sorry, I didn't get what you said earlier because my mic, my this thing was having issues. So I think it's working now.
Okay, so when we say from the left or from the right, the 4.9, let's say we have a value at this straight line is our value. This is how it approaches. 4.9 means that it's approaching from the right.
Okay.
It's approaching from the left, rather. So while this one is approaching from the right, this one is approaching from the left, the other is approaching from the right. So 4.99, you can see that it has different grades. 4.999 is lower than 4.99, which is lower than 4.9, which then we enter 5. But do you see that it's moving? If we arrange it on a number line, it means that we have 4.999 here. It's approaching, right? It goes to 4.99, it's approaching. It goes to 4.9, it's approaching. Still from where? The left, right? Then it gets to what? 5. Okay,
So
5.0.
Or the negative. Isn't the left supposed to be negative?
No. That's what we're trying to explain. That it does not mean addition. It does not mean subtraction. It does not mean per se negative. It means that it is approaching from the left, or it is approaching from the right. The left will contain smaller numbers. Okay, so smaller numbers. So this one, if I arrange this well to be 5.001, then to keep going 5.01. To keep going 5.1. To keep going 5.2, right? Are you saying it approaches, it gets, okay, so that is approach.
Okay.
Yeah, as it approaches from the right or as it approaches from the left, the meaning. So what I explained now is from the left. So if we calculate it from the right, it means that let's say this value now wants to approach this from the right. So it's going to start from here. It's approaching from the right, right? So it's approaching the value from the right. So it goes, to keep going, to keep closing the gap. It gets to
Okay.
the value. Do you see that? So this one is approaching from the right. This one is approaching from the left. That's the meaning. So you can have the limit in two ways of its approach. One is from the right, one is from the left. So sometimes you see the equation and then they will put a minus there or they'll put a plus there. What they want you to do is to try the numbers, to put it properly so you can see your number. Because, okay, let's take, for instance, let's take an example. It's good, at least we understand limits, right? So let's take this. Let's say we have the limit of, okay, first of all, let's put this, the function of x is read as 2x plus 1, okay? And then we have our limit of that 2x plus 1 as x approaches 3 from the left. I think as x approaches 3 from the left. So we go from the left and then we try the number. So first of all, let's try this number. The answer, normally, if we just put in, if we put in 3 or substitute 3 there, what do we have if we put this? If we just substitute 3, like we replace, what do we have when we replace?
7.
7, good. So that means your answers must be going towards 7. It must be approaching 7.
Beginning from
it will start from around 6. Okay, so your answers, because they will put this in options, right? So they can put like 3 things in the option. They can say this one now, it means our answer should be close to 7. So it means it's approaching 7 from the left. So we can have 6 point, let's say we have 6.8. The other one can be 6 point. Okay, sorry. Let's say we have 6.998. The other one now can be what? 6.99. The other one now can be what? 6.9. Do you understand? So if you see it, you just know that, okay, this is the right answer. This one approaches, because they can also drop answers like this. They can drop options like 2.999. And you think it is minus that we're doing. Then someone will now go and subtract. Then you just pick 2.99, 2.99, and 2.9. Then you just pick this answer, and then that will be wrong. This is the one that approaches 7. So it doesn't necessarily, we just check the one that approaches, and this one says it approaches it from the left. Okay, so it is approaching that 7 from the left. So what if it is approaching this 7 from the right? Let's say we have the limit of 2x plus 1. The same thing now. The limit 2x plus 1, and then we have x is approaching 3 from the right. So we're going to use the approach from the right. So the approach from the right will be what? Is it going to be around 6, or is it going to be around 7?
Should be around 7 down.
Yes, thank you, around 7. So it means that this is our main guy, 7. So we're going to have approach from the right. It's going to approach it from the right hand side. So it means that we're going to have something like 7.002. Then we keep going like that, 7.02. Then it keeps, we approach, keeps going like that. Then this one can be 7.2. So we're going to have that value. The value we just, until we get to what? Until we get to 7.
Quick question.
So let me put this. Well, this one is meant to, what is meant to be here close to this one is the 7.002. Then This will be 7.02, and this is 7.2. Yes, your answer, your question.
Okay, so the how do you know if it's meant to be because or are they going to write it out that as it approach from the left or right, or it's for you to find
No,
out?
you'll see the option. Your option will tell you what to pick. So when you see the option, you just know this is what I'm picking. But you first of all find out because you see options from the left and the right. So you just know, okay, this one is right. This approach is from the right. This approach is from the left. And
Not
you'll
sure.
see it there.
Okay, also the interval now. Is it like we just assume is the spacing is like 7.002, 7.00, maybe 4 until it gets to the start point?
Okay, most times it's plus or minus 0.001. That's what they use on start. But the thing is, that's the option gives us exactly what they are expecting us to do. You get that's what it gives us, what they are expecting us to do. The option gives us that one. So
Okay.
mhm. Okay, so let's take 10 one stretch. Take 10 stretch will be here 7:17. So let's just take 10 minutes and stretch to that time. All right, welcome back. So yeah, I hope we're back. It's just 10 minutes. So we're back. Right. It's just share reaction if you're back. All right, so let's continue. So yeah. So that's just how it looks like. Okay, so just like two people are walking towards the middle of a bridge. Okay, one starts on the left, the other one starts on the right, and then if both meet exactly at the same point, everything is fine. That's exactly what happened. So that is what happens when a limit exists. We have two approach. We have one from the right, we have one from the left. Okay, so that's when the limits exist. So a limit exists only if the left-hand limit approaches the right-hand limit. Okay, so left-hand limit is approaching the left-hand limit approaches the right-hand limit and gives them an equality. So what I mean is, okay, so I'm asking when does a limit exist? When does a limit exist? I said when the limit exists, function limit function of x. Okay, when the left-hand limit equals that of the right-hand limit. So just like I said, there's an approach like a bridge, two people walking towards the middle of a bridge. One starts on the left, the other starts on the right. Well, if they both meet at the same point, exactly the same point, everything is fine. So that's when a limit exists. So it's just like using the bridge principle, and this is the midpoint of the bridge. And then we have this guy walking towards, and then we have another guy here walking towards it. So once they can meet at this point, then everything is fine. So let's consider, let's say we have this, consider this, the function, we have the function of x to be equal to 2 if x is less than 1. And then we have that to be equal to 5 if x is greater than or equal to 1. Okay, so that's it. So then it says find. So I'm sure you remember how we deal with both these kind of cases. So it says find, let's find the limit of the function of x as x. Okay, where are we? We just started, we just resumed. X approaches from the left. Okay, as x approaches from the left. We just started, we just resumed. So we're looking at this. We're talking about when does a limit exist. I said a limit exists when the left-hand limit is equal to the right-hand limit. So I gave an illustration of the matchstick drawing. You can see there. I said, just imagine two people are walking on a bridge and they decide to meet at the midpoint of the bridge. As long as the person, one starts at the left-hand part of the bridge, the other starts at the right. So as long as they meet, okay, exactly at the same point, everything is fine. You understand? So everything is fine. So that is what happens when a limit exists. So we consider those two parts. And then we then have, it says here that find, this question wants to illustrate that find, we should consider we have x the function of x to be 2 as x is less than 1, or 5 as x is greater than or equal to 1. And it says find the limit of the function of x when x approaches 1 from the left. So approaching it from the left. So what's it going to be? So if it is approaching it from the left, so we're going to have our answer to be equal to 2. So if it's approaching it from the left, our answer is equal to 2. Because it is approaching it from the left. This is the one that belongs to, that is less than 1, or it belongs to the left-hand part of the equation, right? So that means this one is on 2. If it's approaching it from the right, okay, it's going to be what? It's going to be 5. All right. So if the limit of the function as x approaches from the right, so if it approaches it from the right, it's going to be what? It's going to be 5. Now, the question here is, does the limit exist? Left is equal to 2, right is equal to 5. Since the two-sided limit does not equal to each other, 2 is not equal to 5, we say that the limit does not exist. This is what they call DNA. I think Danjuma mentioned DNE. DNE means does not exist. So here now we say 2 is not equal to 5, right? So the limit does not exist. That's the DNA. That's what DNA stands for. It simply means that there is no single number that both sides are approaching. That's the meaning. So this is when we determine when a limit exists or when it doesn't. Question?
Okay, so the 2 and 5 are the left and the right limit.
Yes, the 2 and 5 left and right limit.
So the top is always the left and the bottom is always the right.
What do you mean by top and bottom?
Like 2 coming up first, then the 5.
Okay, yes. Approaching, you see that 2 means that if x is less than 1, all right, or if it's coming from the left, less than 1 means it's from the left hand part. So that is 2. Then greater than or equal to 1 means it's from the right hand side, belongs to the right place. So that is 5. That's why we put it here. In our equation before, we do put something like understanding different cases or knowing different cases and all that. So we do put something like that. So we had 2 different cases here, and that's actually what we solved. Okay, so let's do another one so we can understand this properly. Let's do another one. Let's say now we have the limit x squared as x approaches 0. This is just 0. All right. So from the left side, it approaches 0. From the right side, it still approaches 0. There's no even minus or there's no plus here. So it is still 0 because everything, if we impute x as 0, we're still going to get 0, whether it is both right or it is left. So this one is, what kind of question is this? This one is still 0. 1 second. One second. All right, so supposing we have the function of x, and we have this to be, we have x plus 1 when x is less than 2. So we know where this is coming from, the left side. And then we have x plus 3 when x is greater than or equal to 2. When x is greater than or equal to 2. And it says we should find the limit. So let's find it from the left side, and then we'll find it from the right side. So from the left side, what do we have? The function of x. From the left side, what do we have? What's our answer? I think, okay,
X
from the,
plus.
yes, say, yes, go on.
I said x plus 3.
Okay, so from the left side, it is what? The left side is the one that is less than, right? So that's the left side. So what this is going to be will be 2 plus 1 equals 3. That's going to be the left side. And then let's calculate as it approaches from the right side. So from the right side is going to be 2 plus 3, and that is equal to 5. So we're having 3, we're having 5. This is a DNE. That's a DNE. Okay. Does not exist. That limit does not exist. So the DME. So if left is equal to right, limit exists. If left is not equal to right, limit does not exist. So that's how we check if limits exist or if they do not exist. So it's just a brief. Yeah, question?
Can I see the question again? The answer, just this one. Where is the question? Like the question. Okay, everything is here.
Yeah, this is the question. It starts from here.
Okay.
This is the question. So it now says find. This is left and this is right. 2 minus is left, 2 plus is right.
So if I'm to read this question now, I will say find the limit of x when x is approaching 2, or when x is approaching 2 from the left because of the negative sign.
Yeah.
Okay. So for this, I have to did I have to solve for x first from the for the first
So
one?
from the left hand side is going to be the one with the less than sign. From the right hand side is going to be the one with the greater than sign.
Okay. Okay. So x plus 1. Please let me write it down first.
No problem.
X plus 2 and limit of x. Say x equals plus 1 to 3. Right. We say
Okay, so are we good?
okay. Okay.
All right. Ah, Ishak, you're here.
you, boss.
Welcome. Okay, let's. All right. So the next thing we're going to look at is we're going to look at evaluating limits using direct substitution method. It's just the same thing that we've done before. Okay. So when can we use replace? Like when can we use direct substitution under limits? When can we use direct substitution under limits? So direct substitution works for most functions, all right? So when dealing with direct substitution, you see equations like polynomials. We can use direct substitution. Just substitute whatever they give to you. You see linear functions. We can use direct substitution. You see quadratics. Quadratic function, the one you have a parabola. We can use that. Cubic functions. We can use exponential. We can use square roots. Square root functions. We can use that. When we can use functions in direct substitution. Okay, you can use it in any of that. So questions like direct substitution is something like we've done before in our previous examples that we're given, things that we've done before. So let's say we have the limit. We have the limit of 2x plus 5 as x approaches 4. So you know what to do. You replace the 4 and we get our value. So we already know. We know this one. So that's, yeah, that's it. So yes, what if we have direct substitution with fractions? So please, someone should give us the answer to this. What's the answer? 13, correct. All right, so what if we have something like this? The limit, we have the limit of x plus 3 over x plus 1 as x approaches 2. So what's going to be our answer?
Let's try that. I
What?
think
Sorry?
direct substitution will not work here because it's going to be 0 over 0. Sorry. I didn't get the first one. Let me work it.
Okay. Let's substitute.
When x is 2,
I think 5 over 3.
Yes, you guys are correct. That is 5 over 3. That is correct. 5 over 3. So what if we have the limit? Let's take the limit of x squared plus 1 over x plus 4 as x approaches 1. Yes, 2 over 5. That is correct. So what if we have
Sorry, is there a reason why you are putting this inside boxes like this 2/5 now? Is that how it's going to be represented in questions or?
No, no worry. I just developed new style. Yeah. Progress. Okay. I just dey put them. 2/5 is the answer. No worry yourself. Let's say we're trying to evaluate this. Evaluate the limit of Euler to the power of x, or Euler exponent x, as x approaches 1.
Will I say Euler rest? Just Euler, because if it's supposed
Yes.
to be 1, it's going to still be Euler.
Yeah. Yes, Euler. So direct substitution actually fails. We have situations where direct substitution fails. For instance, Princess, what's going on? When we
I
have,
got this. Oh,
you got what?
I said I got my network. I got disconnected.
Oh, sorry.
This is going to be 0/0, which is not accepted.
Yes, it's not accepted. So it's not accepted because it's giving us an indeterminate form. This is what Danjuma was saying about indeterminate form. Professor Danjuma, she said this one is going to give us an indeterminate form because it has no definite value. No definite value. It's going to give us like 0/0. So we cannot say that the answer is 0. It has no definite value. It's called an indeterminate form. An indeterminate form means that we do not yet have enough information to determine the limit. That's what it means. Okay.
Can you spell the indeterminate, please?
Okay, so when we have 0/0, it means that it is indeterminate. It is indeterminate. So when you have 0/0, when you have infinity over infinity, these are indeterminate form. When you have let's say you have 0 times infinity, these are things like, or you have 0 raised to power 0, or you have 1 raised to power infinity. All these are indeterminate forms. They will give us you know, in the time you have infinity raised to power 0, or which other one? You have 0 times infinity. Yeah, all these are, they are indeterminate form. But don't worry about this one. We'll get to understand it next. So the thing is, when you have 0/0, things like this is now when you can now try by factoring. You can try by rationalization. You can try by trigonometric identities, or then you try by L'Hopital's rule. So when it gives you indeterminate, that's when you now apply that guy, L'Hopital. We're getting there. Don't worry. We'll soon touch it.
Does it
So
mean I haven't gotten the
yes,
answer for this because it's indeterminate, given that we arrived at 0/0? So we need to use another method for this.
yes, we need to use another method for it. That's the meaning.
So that means this answer is not valid. It's not supposed to be like that.
Yes, it's indeterminate. It's not acceptable.
So we should have a way of getting an actual value.
Yes.
Okay.
So we're going to learn how to factor. All right. We'll evaluate limits by factoring. So that's what we're going to be learning now. Yes, please. We'll learn it by factorization. So to factor means to writing an expression as the product of two or more simpler expressions. So yes, we're going to learn limits. Let me put it here. Limits. Like I said, I just wanted us to break down every steps. Limits of factoring. Get solid foundation inside. Yes. Oh, yes. Princess, yes.
Please, I'm sorry for taking you back. Can you please do a rundown of the is it direct substitution? Because that was where I got off. Please.
Okay. So the direct substitution is just like the one we did when we started limits, replace, 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 like this one, the one we did on this page. Okay, when we started limits, that's what the direct substitution is. Okay, but it's just that under the direct substitution, we sometimes we get to an indeterminate form. Indeterminate form means that we get 0/0. It does not have enough. All right, it does not have enough data. Okay, it does not have enough data to continue that limit. So instead of we solving, when we have 0/0, we try by factoring. Okay, so there are different ways that we try this. So we try by factoring the equation. You can use factoring the equation as an example. You can use rationalization. You can use trigonometric identities, or use the L'Hopital's rule. So when we have 0/0, so that's actually what we got here. Here now we did the direct substitution. We just replaced by 2. We had 2 squared minus 4 over 2 minus 2. That is 0, and that is 4 minus 4, 0/0. That is indeterminate. So in order for us to solve things that are indeterminate, we need to learn about evaluating limits by factoring. So let's go into the factoring mode. We'll learn the factoring. So by the time you finish this, you should understand like direct substitution sometimes we fail. Then how you're going to factorize algebraic expressions correctly. Then you can, just like you dealing with algebraic fractions. When I think that is grade 11 SS2, algebraic fractions, that kind of thing. So that's exactly what you're going to do. When you reach the 0/0, you need another method. So of factoring. So how do we then factor limits? Okay, how do we factor limits? First thing first, we have what we call factoring means writing an expression as the product of two or more simpler expression. More simpler expression. For instance, we have difference of 2 squares where we have x squared minus 9. This is a difference of 2 squares, meaning there are 2 perfect squares. X squared is a perfect square, 9 is a perfect square. A perfect square is perfect squares are values that we can find their square root. So it means that we can find the square root of 9. We can also find the square root of x squared. So these are perfect square. And if you want to factorize perfect squares, what you do is you open 2 parentheses. One has a minus, one has a plus, and then you put in the square root of the first value, which is x, put in the square root of the second value, which is 9. That is square root of 9 is 3. And you have factorized the difference of 2 squares. So it's very important why we have to factor limit. Let's go back to this question here, this one here that says x squared minus 4 over x minus 2. And since we cannot use direct substitution, we're going to use factoring. So now for this one, we continue. We say that the limit was of x squared minus 4 over x minus 2 as x approaches 2. Since direct substitution cannot work, this is a difference of 2 square. I can see a perfect square here. So I just factorize. So I'm going to have x minus 2, x plus 2. Then I have here x minus 2. I can cancel out x minus 2, and then I'm left with what? Just x plus 2. Do you see that? And then as x approaches 2, we still have our limit. Don't forget, as x approaches 2, so that means this is 2 plus 2, and our answer is 4. So by factorization, you use that to cancel out whatever that cannot work. You cancel it out. Whatever thing that can cancel it out, bring it out. Okay.
But the square root was on n only.
The square root of what?
In the factorized this thing is on x. But we had to factor out we have to split it as if there are two, like as if it was x minus 4 in bracket square.
Okay, if it was x minus 4 in bracket square, that is x minus 4, x minus 4. That one is quite different. This one, we factorize what is inside, because what is inside is difference of two squares. We have difference of two perfect squares, just like what I did here. This is called difference of two squares. So it is difference. That's difference of two squares. That's how you do it. Open two parentheses, one has a minus, one has a plus. Find the square root and you put it inside.
Okay, so what's the main difference between the x squared minus 4, for instance, and x minus 4 square, like x minus 4 in bracket square?
X minus 4 square means that this is a perfect square on its own. It's not a difference of two square.
Okay.
This means x minus 4, x minus 4. That is x minus 4 twice. Do you understand? So, and if you expand that, you're going to be getting, you're going to be getting x squared minus 8x plus 16, as if you're going into the expansion. But that's the meaning. Okay. So, it means x minus 4, x minus 4. Let's try something. Let's use factoring when we can see that this thing doesn't work. So let's use factoring. So let's say we have the limit.
I haven't written the previous one though.
Oh, okay. Okay. All right. Just let me know when you're done.
All right. Sure.
Okay. Are you done?
Yes, thank you.
All right, so let's continue. So let's say we have it for, just take this other one. We have the limits of x squared minus 25 over x minus 5, and as x approaches 5. So we cannot use direct substitution for this because it gives us an indeterminate form. So what we're going to do, quite simple, we say what? We factorize. So this becomes, let's factorize x squared. This is difference of 2 squared. You can see two perfect squares there. One will have a minus, one will have a plus. X squared minus 25, that's difference of 2 squared. And then we have x, 25 square root is 5 and 5. Then this is over x minus 5, right? And so we cut out. So we're left with what? X plus 5. We come back to this limit x plus 5. And this would be 5 plus 5. And that is 10. So if we cannot use direct substitution, we use this one. All right. So cannot use direct substitution, we use this. Okay, what if we don't have difference of 2 squared? What if we have a quadratic? What if we have a quadratic? All right, just let me know if I can go further. What if it's a quadratic that we have? So let's say I have evaluate, say we're asked to evaluate this kind of question. Evaluate the limit of x squared plus x minus 6 over x minus 2 if x approaches, as x approaches 2. So what if it's this? If you use direct substitution for this, 4 plus 2, 6 minus 6, you're going to have 0, 0 over 0. So this is indeterminate. So for this, you have to factorize the quadratic equation. All right, factorize the quadratic equation and then cancel one thing out. So let us factorize this, attempt it maybe 1 minute. So let's factorize this and let's cancel out. What are we left with?
X plus 2. X plus 3.
Okay, so we're left with what? X plus 3. Now, one thing we need to know about factorization is we look at the values that is gotten. So we look at the values. All right, so for those you're not getting how to factorize a quadratic equation. So look at this. We bring this together, we have negative 6x squared. We now look at two values that when we two values of 6, right, that when we add it's going to give us 1. So what are the values of 6? We look for the factors of 6, 1 and 6. The next is 2 and 3. If I add or subtract 2 and 3, I'm going to get 1, right? So it means we look at the sign behind this middle term. It is positive, so the bigger number has to be positive, and this is what we have, right? So that means this is what I'm going to pick. So we just have x minus 2, and then we have x plus 3, and that's how we factorize quadratic equations like this. As long as a is equal to 1, that's how we factorize quadratic equations. And we can then put it here. So that's why we're left with x plus 3. That's how they got it. So it means that this one now would be x minus 2 and x plus 3 over x minus 2, and then we're left with just x plus 3. So we have the limit as x approaches 2 to x plus 3, and yep, you're correct. That is 5. That is, yes, princess, that is correct.
Hi,
Yes,
I beg,
Prince.
no, let's say I dey ask so many questions. Please, can you explain this, please? I don't get it. This
Is it how to factorize?
yes, this x squared plus x minus 6.
Oh, all right. So what we did here is factorization. So we factorize quadratic equation. That's what we did. All right, factorization of quadratic equations. Okay. So in factorization of quadratic equations, how you do it is you multiply the first term you're seeing there and the last term together. If you multiply that, you're going to have minus 6x squared. That is negative 6 times x squared, right? Now, what you're going to do next is you look for the factors of 6 that when you add or subtract is going to give you plus 1. The coefficient of x here is 1, right? So that's plus 1x. So we now tried 1 and 6. If I add or subtract 1 and 6, I'm not going to get 1. The next factor of 6 is 2 times 3, right? So if I add and subtract 2 and 3, I will get 1. So I looked at the sign behind this middle term, which is what I'm trying to get. The sign is positive, so my bigger number has to be positive. And then we put it there. So that's the other one will be negative. So 3 minus 2 will give me 1. So I factorize. So what you just do, you just say the x minus 2 and then the x plus 3. This equation has been factorized. You can do it like that, although we do things like this. This is a shortcut when, as long as we don't have a value behind x squared. If there's a value behind x squared, then we have to do the long method and complete our quadratic equation factorization. But as long as it's just simple like this, you don't have any problem. You're good to go. So from here, you bring out your factors, you factorize it, and then we do our normal thing. I know. Okay, let's treat another one so you understand it. You
Would you say
understand it
the
better.
combination of the substitution method and the factorization?
Substitution and factorization. I don't understand you.
Since after solving for the x plus 3, we have to now, as x approaches 2, we have to now say 2 plus 3 to get the final answer.
Yes, that's what we did here. So the limit of, because x minus 2, we cancel x minus 2. If you can look at the board, if you see it here, this side, x minus 2, we cancel x minus 2, we're left with x plus 3, and then as x approaches 2, we have 2 plus 3, and that is equal to 5.
Okay. So I was concerned about the last part where we have x plus 3. So it's not like we are substituting. We are just trying to find the limits now as x approaches 2, right?
Exactly.
Okay.
So our answer here is equal to 5. Okay. So let's try another one. Let's say that okay, let's do another one so you can understand princess. Let's say we have the limit x squared plus 5x plus 6 over x plus 2 as x approaches negative 2. Okay, so if we do this, if we impute negative 2 into that answer, or we use direct substitution, we're going to get 0. So we're going to factorize. Let's factorize x squared plus 5x plus 6. So I multiply the first and last term. It's going to give me 6x squared. I look for factors of 6 that when I add or subtract is going to give me 5, the middle term. So we try with 1 and 6, 1 times 6. If I add or subtract 1 and 6, will I get 5? I think so, yes. 6 minus 1 is 5. Then the sign behind what I'm getting, what I'm looking for here is positive. So this stays here. This is negative. Then I have x and x. So that means I have x minus 1. And then I have x plus 6. But now, if you use that your values are going to be wrong because you try and use the first one where you have negative x and 6. The reason is this. Let me tell you the reason. Let me tell you why the reason is this. When you multiply it together, what you're going to get will be negative 6x squared. So if you approach it like that, this is another thing you need to look at because people make this mistake. So when you approach it like that, you're getting 6x squared instead of positive 6x squared. You know, when we multiply the first term and the last term, what we're getting is, what we got was 6x squared. When we use this one, it's going to give us 5x. That's very good, very correct. We can choose to get that, but that's a big mistake because when we multiply it together, it's giving us negative 6x squared and not positive 6x squared. So what do? Continue on the factors. So if we try 2 and 3, 2 times 3 is going to give us 6, right? So if I add this together, I know that I'm going to get, they're all positive. 3 plus 2 is 5. So I can use this one. And if I multiply it together, I will have 6x squared. So it is very, very correct. 3 times 2 will give me positive 6. So instead, I'm going to use this. This will be x plus 2 and then x plus 3. This is how we factorize, and this is how we check. Understand that the factors you're using, you have to multiply it so it gives you what you have here, and then you have to add it or subtract so it gives you the middle term. If any of them doesn't match, it means that your equation or what you're using is incorrect. So we have x plus 2 and x plus 3. So then we can go on and solve. We can keep solving this one. This one says the limit of as x approaches negative 2, right? So we have x plus 2 now, and then we have x plus 3, right? Then over x plus 2. So x plus 2 cancels out. We're left with just x plus 3. And so our limit would be negative 2 plus 3, and that is equal to 1. So I hope you understand now, Princess. Do you understand?
Yes, a bit.
A what? A bit. Okay. Let's do this one. Do this one. I will zoom out. I just want to write this question. We have a limit of x squared plus 3x plus 2 over x plus 1 as x approaches negative 1. So try this one.
I can't see the question.
The limit x squared plus 3x plus 2 over x plus 1 as x approaches negative 1.
Are we to say the answer?
Oh, yes.
Okay. I tried my best. I was able to get 1 as my answer.
All right.
1. I got 1.
1. Yeah, 1 is correct. 1 is correct. So there are various practice exercise as well. Well, we're still on the marathon. Let's go.
Oh, is as x approaches -2?
No, as x approaches -1. You're correct. Oh, the other side is, man, this is the question.
Okay. Okay.
I got one. Is it correct?
Yes, you're correct. One is correct. So you're correct, Princess. All right. So we're